Hey, hello. I'm going to be doing another Bootsector game here today. So 512 bytes or less of 16-bit x86 assembly, real mode. Maybe using a BIOS interrupter too. This will be over a sort of one-screen Space Invaders-ish level. I'll be typing up something similar to this. And we got the aliens moving at the top. They're kind of doing jumping jacks for lack of better, artistry here. We have a few shots. We got the barriers here. We got the player moving left and right. You can shoot your own shot. It's kind of blue instead of yellow for the invaders ones there. If you hit them, they disappear. They go left, right, and down. If you hit the barriers, they are destructible. So it kind of removes the pixel when you hit it. It's for the player and the alien shot. And then if you get hit, the game kind of ends. Right now, it just kind of pauses until you press a key and it'll jump and reload the reset vector and everything. So it'll start back over again. But that's pretty much what I'm going to be doing today. This is the actual VGA mode 13 in hex graphics mode here. So I guess these are technically sprites. They're kind of simple, like 4-byte bit mapped sprites, which I'll get to in a bit. But yeah, I didn't use all 512 bytes. I used, most of them though. I only had about 5 bytes left available. But anyway, other people have done Space Invaders and it's more complete, more complex. They used less code. This is just my sort of basic example. But hopefully you'll learn a thing or two about maybe some space saving optimization techniques or instructions, or maybe a different way of laying out your stuff. But I'll try and get to it, I guess. Make a test folder and I'll just go into there. Let's do $_ and I'll just copy everything into here, except for the directory itself, of course. Okay. We'll remove the bin file. I could go through and explain like this as it is, but I think retyping it up will kind of force me to explain myself, so I'm going to go with that. But okay, to start off, it's going to be similar to the last ones. I'm probably going to do like a standard game loop and go through and draw everything, take player input, and just keep, iterating through the loop with a set delay, probably a 1 or 2 timer tick delay. And I'll try to go through and explain like examples as I'm writing the code to show, various stages of development. Hopefully it makes more sense because you'll be able to see it visually as we're going through it. This will take longer than if I was just kind of code reviewing my current stuff. So this video might be a few hours, hopefully it's less, but we'll see what happens. But to start off, x86 boots up in 16-bit real mode, still if you're on a BIOS supported platform. So the 511 and 512th byte of the first sector on the disk that you want to boot from needs a specific boot signature for BIOS compatibility. But the boot signature, so the 511 and 512th bytes of the first sector is going to be AA55 in hex. You can write hex in one of two ways here. You can, if you're writing it starting with A through F, you'll need to prep end with a 0. Otherwise, you can do 0x and take off the H on the end. Either way, I usually like doing the little H on the end. I don't know why. I think it looks neat, but I'm just going to put the boot signature here first. Just to say it's going to boot. This is a word, so I'm going to define the word at this point. There's a couple different ways to put this at the 511 and 512 byte positions within NetWide Assembler. To be compatible with other assemblers, if you want to specify, hey, I want you to use 16-bit code, in NASM you don't really need to do this, but if you want to be super explicit with it, you can put use 16 to be compatible with other assemblers, or you can do bits 16. They're both equivalent. It just ensures that NASM uses 16-bit code, although by default it's going to use 16-bit if you don't specify like bits 32 or 64. So one of two ways to put this boot signature at the end of the sector is by doing what I'm going to call traditional way in other assemblers is times. So like times 510 minus the current position in the file minus like the start of the memory segment or what have you. So this is going to fill 510 whatever, we'll say bytes of 0. So 510 0 bytes, and this boot signature would be at the 511 and 512th byte. So you can either do that, or another way is setting in a specific section in NetWide Assembler. So we can say this section is going to be called the boot signature section, let's say, and we're going to start it physically at memory address, let's do 7DFE. So I'm choosing that for a specific reason. let's do the origin here. We'll start it out at 7C00H. In x86, when you boot up in real mode, it searches the reset vector, which is at like FFFF0 hex in memory. And yeah, with the 0 on the end. And at that reset vector, there's like a word location there that has the address that it then jumps to and executes code, set up the BIOS and everything. But anyway, eventually, your boot sector here, if it finds the boot signature at the end of the sector, your boot sector is loaded to memory address 7C00 in memory when your PC boots up. So if we start our addressing and our offsets from addressing at 7C00, then this code will be found and booted from in like an emulator and QEMU. We'll use the times first and then the other. And yeah, I don't really want to do anything. I'm just going to halt and do nothing. So I'm going to clear interrupts and halt just so nothing happens. But I want to show that it does boot, right? So make files, still using, yeah, I'm using NetWide assembler. I don't think I need the phony here for this, but this just helps to ensure that this is run every time, whether the file changed or not. Although it doesn't have prerequisites, so I think it's going to run all the time anyway, but regardless, I'm using NetWide assembler. I'm going to make the output a flat binary file, so -F to format the output into a binary, bin, give it the source file, -O for the output name if wanted, and then I'm giving it the same name with a .bin extension. And then to run this, I'm using QEMU emulator system, QEMU i386 specifically. If you leave off the drive parameters here, then it will give you a little message that says, couldn't really find the right format for this drive you're using. It looks like a raw binary. So if you want to kind of suppress that error message, you can just give it a specific drive here. So -drive format is going to be a raw. It's kind of a raw binary file. And the file we're using as a raw binary file is this invaders-ish.bin that I'm calling it here. So it's going to run this. It'll probably assume a hard disk or a floppy disk. I think it does a hard disk by default because I didn't specify, or I did a regular drive. So we do make run. It doesn't work because we have to do make first. To make the file, then we make run it. So I think, yeah, it assumes it's a hard disk. It is booting because it has a little flashing cursor there. A little blinking light. Actually, before I do that, let me show, okay, XXD, get a hex dump. So we have the FAF4. This is kind of the clear interrupts and halt commands here. But the 510 or 511, 512th bytes is the boot signature. So we put that there. This is using the times directive. I just want to show its equivalent with the section directive kind of here, just so you can see it does the same thing. If you're doing explicit sections like this in NetWide assembler start, if you use regular start equals, this will be the address that this starts at. If you do vstart equals, this is sort of a virtual start address. And if you define something here, like with a label, then when you refer to this label, it will be offset from this vstart address. So if we had like data here, we had like label 1 is going to be a word. If we reference label 1 and moved it into like AX or something, our label here, then the address or the value moved into AX right now would be 7DFE. So I'm not going to be using that in this video. I just for your information, if you cared. Maybe you don't care. That's fine. But okay, I'll get onto it. 7DFE is a 511 bytes after 7C00 is why I'm doing this. But this should be equivalent. So if we make it and run it again, we have, the same thing. We make run, we'll get the same result. So those are the same. I like using the times directive because in NetWide assembler, if you run over this, it'll give you an error and it'll say like times -3 is invalid or something. So you'll be like, okay, I went 3 bytes over my limit for this sector. So that's an easy way to see, how much space this stuff is taken up later if you're going to overrun this. If you overrun by like byte 513, it'll say, hey, times -3. That's not right. In the Pong and the Snake, I think I just used text mode, right? VGA mode 3H, which I think the PC boots up in by default. So you don't really have to set that. But maybe some BIOSes don't. But I'm going to explicitly set VGA mode 13. Let's do setup video mode, setup graphics mode. We're going to use VGA mode 13H. It is 320 by 200, so 320 pixels wide, 200 pixels tall. It has 256 colors. It has 8 bits per pixel, so you can refer to each pixel on the screen with just 1 byte for the color to set it, so it's pretty easy. And it is a linear frame buffer, or linear, video memory array, starting at address A0000, A quad zeros. Text mode, monochrome text mode starts at B, quad zeros. Color text mode starts at B, 8000. We're using regular graphics mode, it starts at this address. To set that up and to use it, we use the BIOS interrupt 10H for video services, so we're going to be doing that. And I'm just going to move 13 into AL, so AH has to be 0 to set the video mode, and then AL is the mode number. We want to use 13 hex for the mode. We're setting the video mode AH0. We use int10 to execute that. If I run this right now, the screen probably isn't going to change size, but it will not show the text. It'll be all black and be doing nothing. Right, yeah. So we're technically in the video mode. We loaded it, we're booted, although we're halting doing nothing at the moment, but it's all black. So if you want to draw like a color or something a little more exciting, we can set a color. So I guess the easiest way to do that would be just to iterate through all the pixels in the screen, set them to a specific color. So we can do that to start off. So let's do like 4 is red, I believe, the VGA color red. So I'll put VGA red. We do have 256 colors to work with, but okay, we'll iterate through all the pixels on the screen. So how many pixels are there? There's 320 by 200 if we want to do byte granularity. For this purpose, we can make it a little more efficient, refer to it as like words, write 2 bytes at a time, but to be simple, we'll just write 1 byte at a time. To actually write to the video address, however, we need to set up our segments a little bit. So video memory, so it does start at A quadruple 0. We cannot move directly into a segment register. I'm going to be using ESDI to write to the screen. So let's just XOR this first. We'll set DI to 0 to refer to the origin, the top left 00 on the screen. But x86 real mode, 16-bit on your processor, it still has segmented memory model. The extra segment, DI is offset from that if we want to do operations like store string word, store string byte, move string byte, stuff like that to move data into wherever DI is pointing to. But when we do something like store string byte, and this moves into ESDI, the data at AL, if we do this instruction, right? So we need ES to be set to somewhere that we want to write to. If we leave ES alone right now, it's pointing to, I think, 0. So we can offset from 0 and write to there, but that doesn't help us because our screen is set up from A0000. So if we set ES to that, then if we write to DI with something like store string byte, it'll write the byte to the screen pixel and we'll see the results. We can set up ES, but we can't directly write to it. If we do like, A000, say, we can't directly move that into ES. We'll get an error. It's an invalid combination. It's at line 12, which is here. So we can't move it into AX first and then move that into ES, and that'll work. Or if we want to save a couple bytes, because we only have 510 effectively to work with here, we can push the value instead, and then we can pop it into ES. So if we move a word value into AX, that'll be a 3-byte move operation, and then if we move AX into ES, that'll be sort of a 2-byte operation. If we push the value instead, that's 3 bytes, and then if we pop it into a register, that's 1 byte. So we'd be saving a byte overall if we just need to move this value into here. So not much, but 1 byte saved is 1 byte we don't have to worry about, so that's good. So ES will point to a quadruple 0. I'm only moving a triple 0 into here because in 16-bit mode, the segment registers implicitly multiply by 16. So when we move this into ES, ES will actually point to this. It'll multiply it by 16, and that's what we can offset from. That was a way of saving space and still using their 16-bit registers when they wanted them for a wider range of memory available to be addressed at the time, but oh well. But we can offset from DI now that ES is pointing here with something like store string byte and write to the screen. Since I set CX with the number of bytes we want to write, the number of pixels we want to write, I can do a repeat prefix on store string byte. So this will write ESDI, it'll move AL into there, CX number of times. Okay, so the screen should be red right now after we do that. There we go, it's red, so that's good. Looks a little intense. Might be able to hear some distant Doomslayer music or something, but yeah, we got a red screen. We can't really do much with that, but you know, it's a base to work with just to show that, hey, we can write to the screen. So that's good. Okay, let's set up what will become the actual loop here, the actual game loop that we're going to work with, our game logic. I'm just going to do the really basic loop, which is just a label and then jumping to that label. I'm going to call it game loop because that's simple enough. That's what we're doing. It'll be understood. And at the end of each loop iteration, we're just going to jump back. Eventually we'll have like some kind of game over condition that'll end, you know, the infinite looping. Put an end game and reset. So I'll remember to reset it later. We'll set that as a to-do item. Right now we're just going to have the really simple loop. So this is going to loop infinitely and go back. This is probably just going to write all the pixels too fast to tell if there's artifacting. But even if it did, we wouldn't see it because it's writing over a red pixel with a red pixel. So we wouldn't be able to see any, you know, slowness or anything right now. I guess I can try to either alternate red and another color or just set up our delay here to begin with. So let's set up a sort of delay timer. I'm going to do a 1 tick delay for sort of the smallest appreciable delay we can have. I don't have really granular timekeeping methods. I'm just using timer ticks still. Eventually I might look into other timer reading BIOS interrupts or something. But right now, 1 tick is approximately 18.2 ticks per second. I think there's 18.2 ticks per second. So it's 1/18th per second or whatever, however that math works. So we're delaying each game loop iteration by about, you know, 1/18th of a second or something. However many FPS that is. It's not very high, but it's not terribly low. But okay, how do we get like a timer tick delay? Well, when your BIOS boots up, I don't think it's fully standardized, but there is a sort of BIOS data area in the beginning of RAM, in the beginning of memory. At the real beginning, the true beginning of memory at, you know, address 0, there's the interrupt vector table, which, you know, works with hardware interrupts, or we do int 10H here. When you do this, the BIOS or your hardware will jump to 10H offsets into the interrupt vector table, and then it'll go load whatever functions loaded there and say, okay, you did this video mode thing, we'll go and load that video mode. But you know, there's other stuff too. There's like keyboard buffers and other things. At one specific area in the BIOS data area, at 046C, there is the number of timer ticks since midnight, or since boot. I think it's since midnight. So this gets reset when your computer resets, when it reboots up. But we can use this value to count, you know, how many ticks we're on, and we can just wait 1 tick. So if we move the data at this address into like AX or something in the accumulator, you could put word here to specify, hey, it's a word, but since we're moving into AX, NetWide Assembler is going to say, okay, it's going to be a word value because AX is a word. It's a 16-bit wide register. So yeah, we're going to move that tick into there. We can increment AX, 1 byte operation, just get the next one. And then we can compare what we got to what we now have in AX. We can say, okay, is the current timer ticks, has it reached the next timer tick effectively? Is it itself plus 1? Has it reached that yet? If not, we can jump back and try it again. So let's put a little label here, call it delay timer. I'll call this wait. So we'll jump less than wait. So the dot in front of the label just makes it a local label. So it'll, when this is assembled, this is basically going to be concatenated onto the end of the last sort of global label, the one without the dot. So when this is assembled, it can refer to this label as delay timer dot wait. You know, this is just a way of saying, I want this sort of associated with this, you know, the closest global label. But why do you need the dot? You don't really need the dot. It's just if you have multiple areas in your code that could use the same label to make it easier to read, then you can use the same label as long as you put a dot and it's associated with a different global label. If we had another timer down here, we could use dot wait. Normally, if we just did wait without the dot, it would say, hey, there's, you know, two of these, well, I guess wait is a keyword in asm anyway, but it would say, hey, there's two of these, you know, you can't duplicate these, that's not right. So we can put a dot and all is good. But okay, we'll just indent this stuff. Yeah, so we're gonna wait 1 tick. As long as it hasn't reached the 1 tick limit yet, we're gonna keep waiting until we get there, and then we're just gonna jump back to the game loop. So this again is not gonna do anything right now, but it will slow down our processing a little bit later on, because we can use a defined 1 tick limit to kind of make things move at certain times. Maybe we want our players, like laser shot or whatever, to move up the screen, you know, every 1 tick instead of as fast as the processor's going, or something. It can make things like more predictable. But okay, we can see how fast the 1 tick delay is if we want to put like a test loop around it or something. I'll do that. Let me do that. I'll remove this in a second, but we'll make a little test loop. Let's do, we can move 1, or actually I'll move that into AX. Because here the timer is going to overwrite the value, so I'll do this so AL is 1. AL equals 1, this will be VGA blue. I'll set DI, actually let's put this down here. I'll set DI to, let's say the middle of the screen, so that would be half the height of the screen. So 320 times 100, and then we would add to get to the middle, which would be the X value. Half of 320 is 160, so this should be like the middle pixel of the screen. And after every 1 tick, I will write a byte to the screen, starting at the middle of the screen. That should write blue pixels to the middle. Or, well, it writes a bunch of stuff, actually. Never mind. But you can see it's writing. This is about the 1 tick delay speed. So it's not a great example for showing how fast something moves, but it is an example, and you get pretty colors. This is effectively moving throughout the VGA range. Because you have the first 16 colors, then you have the grayscale, then you have the other colors. But I guess I set up AH wrong when I did this. Oh, because I moved, yeah, I'm storing after the timer. If I stored before the timer, then we would actually have the AL value, and AH would not be affected. So it would all be blue. Yeah, that's what I wanted. Okay, but anyway, that's just a tiny example of drawing pixels. Doesn't really help anybody too much, maybe. But we have our delay timer, our 1 tick loop, so I'm going to break out this, well, first I'm going to set everything basically to 0, so move this up here. So I'm going to set the color 0 every time, just going to clear out the screen. So clear screen on every game loop iteration. And we'll have some sections that we're going to go through, so okay, so I put a bunch of comments here. These are basically going to be the main sections of my game loop logic that I'm going to run through and do. I'm going to draw everything, you know, starting with the aliens, going to draw the barriers, the player ship. I'm going to check if the shots that are currently in play, if we hit anything. So if the alien shots hit the player, we want a game over. If the alien or the player hit a barrier, we're going to erase the pixel of the barrier, kind of destroy it. And if the player shot hit an alien, we kind of want to erase the alien, increase the score or something to get to a win condition eventually. If the shots did not hit anything, we're going to draw them. The alien shots I'm handling a little differently from the player shot. The player kind of, you know, when you press a key, we want to create the shot. The alien ones will sort of always be in play, if you will. When they reach the end of the screen, we're going to create a new one in another sort of random position. I want to move the aliens, you know, according to our timer. Every set amount of time, we're going to move them to the left or right. If they hit the edge, we're going to move them down and, you know, go in the opposite direction. And we'll get the player input, and we'll delay and go back. I did add this line too, just to sort of demarcate a little bit better. I'm going to put all these as sort of to-do items here. So maybe you want to actually draw something on the screen first. All right, so let's go and like draw sprites, because that'll be interesting maybe. So to draw like a sprite on the screen, well, we need the sprite data first of all, and then we need something to draw it on the screen, some code to do that. So let's set up the data. The sprites and some other sort of initial variable values I'm going to put below here, you know, after all the code. I'm going to call this code segment data, and you'll see why in a bit. Sort of, I'm going to move the data segment away from where it's first booted from. I'll put variables down here, but they'll be in a different segment from our running code. Well, they'll be in the same segment as our running code, rather. They'll be in a different segment from where I'm going to like store our variable values. So I just called it this to make more sense, although it's probably confusing right now. 16-bit real mode has, you know, segmented data. The code segment sort of corresponds to the area of memory where your executable code is. The data segment is where your data is going to be, like your variables and stuff. You know, you want to read and write to this to affect, you know, data. That's your data segment. Code segment are these instructions here, like this game loop, this XORs, the moves, the repeat store string byte. This is in your code segment where it's executing the running code according to the instruction pointer and everything. But anyway, let's make some variables down here. We'll set our sprite data up, call it sprites. I'll call it sprite bitmaps. I don't know. We'll have the first alien bitmap here. Call it a alien1 bitmap. These are all going to be 4 bytes. Basically, we're going to check if there is a 0 or a 1 when we go to draw the sprite. If there is a 0, I'm either going to skip over it or just draw like a black pixel for the background. If there is a 1, I'm going to draw whatever the color that the sprite is. So I'm going to sort of read the bitmap and then, you know, check. If it's a 1 or a 0, draw the color, or don't draw the color, draw the background, you know. But they're all going to be, you know, 8 pixels wide and then 4 pixels tall. So and the way I'm doing it like this is so that you can sort of maybe squint out of your corner of your eye and see that this is what the sprite looks like. All these pixels are going to be colored when we draw it. And then the zeros are going to be the background. So we have our little man here saying, hey, we can have a sprite 2-bit map. We kind of want to make him do a jumping jack, so we're just going to move the arms down. And this one will be down here. And then the legs, I kind of moved in one. I did that. So you can see that these are the kind of arms. They're going up and down. The legs are going left and then in. So he's kind of doing sort of jumping jack type deal there. The ship and the bitmap and everything, I might as well just set them up now so I don't have to later. The player ship. Player ship, player ship. And I did one extra on the end. So the ship's not really fancy. It's basically a triangle. It's all right. Maybe a pyramid or something if you have an imagination more than I do. We'll set up the barrier. Okay. So these are my 4 bitmaps I'm going to use. Alien 1, the alternate sprite, Alien 2, the player ship, and the barrier. They're all going to have associated colors as well. But okay, let me make a couple sort of subroutines here. I guess I don't need to call it a subroutine. It'll kind of be self-explanatory. But I'll do a draw a sprite to the screen. We're going to draw sprites in multiple places. So rather than duplicating code somewhere, I'm just going to make it a separate thing down here. We'll call it draw sprite. Right now it's just going to return until I fill it out. And I know another little thing I had was get the current screen position that we're going to draw at. So in order to save a little bit of space, all of the sort of sprite and player and shot X, Y values that are, you know, coordinates on the screen that we want to draw stuff to, I'm going to make all the X and Y values 1 byte, and then I'm going to scale them by 2. So this way there will be no value that is over 255. So normally the range of X values here in pixels would be from 0 to 319 for the 320 by 200, you know, screen we have. If we divide 320 by 2, we get 160. That's less than 255. Everything fits into a 1 byte value. So, you know, save a little bit of space that way, I guess. Get screen position. Let's set up some, maybe some constants first as well to get rid of these, like, magic numbers, right? Let's get rid of some magic numbers. Set up some constants here, like colors and things. You can do these a couple ways in NetWide Assembler. You can do like a define, I think, or an EQU. I just use EQU because for me it's shorter. So the alien, I'm going to make these all 1 byte values. Alien color is 2. This is going to be 2 is going to be green. 4 is red, as you saw before. Let's do player color is going to be 7, which I think is gray. I think it's 7. Let's do barrier color. Oh, I did use some above the normal 16 colors actually. 27. What is that? That's like a red. It's kind of like a red, a bright red orange. but I'll just call it red. It's not the regular 4 red, but it's a little different. Okay, I'll set player shot color. Player shot color, we're going to do cyan, which is going to be B. And can I copy? There we go. And we'll do alien shot color. That's going to be yellow, which is E, I think. Yeah. So when we draw them on the screen later, we'll you know, put the right color in before we draw. Let's do like screen width and height. Call it screen W or screen width. It's going to be 320 pixels. Screen height. It's going to be 200. All right. And then the equivalent down here would be screen width times screen height. You know, so that's kind of unambiguous. You're like, what is the 320 for? Like, oh yeah, now I see what we're doing. We're multiplying the width times the height. That might make a little more sense. You know, we can have our video memory address, although we only really use this once, so this kind of isn't necessary, but oh well. I don't like a bunch of magic numbers. Except for these. These are sprites. These are okay. Those can be magic numbers. But I'll do the timer address as well. Let's go here, and then we can do timer. Just because it's easier to remember later on. It's easier to work with. But alright, so I'm going to do this also a little bit probably weirder maybe than the last two, maybe what people are used to. I did buy actually books from one Oscar Toledo, who's he's a very smart guy. He did a better version of Invaders actually, which inspired me to do this video in a worse manner than what he did. But one thing that I learned from that was, you know, you can reference data, like let's say we have this video address A_0. If we put data beyond the screen address, then we can still read and write to that. After we do like a loop here, you know, after this, DI is going to be pointing to, you know, the area after screen memory, which for our case, 320 by 200 equates to, you know, 64,000 exactly. Or in hex, that's FA00. So if we put data at this address here, then we can reference this data without having to do anything after we, you know, sort of do our initial writes to the screen. So we won't have to do anything extra to reference data like move variable names and addresses around. We'll already be pointing to that area. We can use that to our advantage. So I'm going to set up some variables up here in that sort of memory. I'll call it like, what do I call it? Defined variables after memory or something. Defined variables after screen memory. Let's be really explicit with it. Put this over here. Yeah, 320 times 200 equals 64,000 or FA00 in hex. So I'm going to start our sprites here, which this is sprite bitmaps. So as long as I don't call it the same label name, it won't be the same. So we can use it. It won't be confusing. But we'll start our sprites off at FA00. So after the screen is written to, at this point, like when we go to draw the aliens, but DI now points to AFA00. Well, ESDI, not just DI. DI points to FA00 at this point. ESDI points to AFA00. But anyway, I can move this value into DI and it'll point to the right area right after our screen memory is what I'm trying to get at here. So our sprites will start here. We'll have the alien one just be offset from the same position. Alien 2, since each sprite is 4 bytes, this will be at 04. We'll have the ship bitmap be offset, you know, 4 bytes after that, so 08. And then the barrier array, we'll put the barriers right after the ship at 0C for 12. For this game to work, I stored 5 barriers in memory at this address. So instead of taking up the regular 4 bytes for the sprite, it's going to take up 4 times 5 or 20 bytes. I'm going to store the barrier here 5 times for 5 barriers, just so they're consistent. And when you like destroy a pixel of the barrier, it'll stay destroyed. It won't like reset every time we draw it in the game loop. Okay, I did arrays. So let's set. So what is 12 plus 20? That's 32, right? So 12 plus 20 is 32, which would be just 20. I think that's right. C plus 20 is, yeah, 32. Okay. 0FA 20. Okay, then we have I have an array of barriers here, I guess. Oh, this can be the array. Yeah, let's do that. This will be the array of barriers. Okay, and this will be the array of aliens. So what I'm doing here is I'm going to have 2 bytes, or 1 word. No, I'm going to have 2 words. Never mind. I'm going to have 2 words, or 1 double word. And this is going to be the number of aliens left in play. So I'm going to have 4 rows of 8 on the screen for 32. So 32 bits, 32 aliens. That's what I'm going to use for the game. If you hit all 32, then you're good. Okay, then I had a player X value. Player Y value is going to be constant, so we don't need to make it a variable. 32 plus 4 is going to be 34, so we'll do 2, 4. I'll have an array of shots, like the player shot and the alien shots going up and down the screen, destroying things, what have you. And that'll be after, so that's 0FA25, because this X value will be 1 byte. The shots, I'm going to have 4 XY shot values. I'm going to do Y first, though, to save some effort later. So it'll be YX, so that'll be 8 bytes. And then I'm going to have the alien position, so 25, so that's 37 plus 8 is 45. What was it, 13? 5 plus 8 is 13, right? So that would be C. 13's D, okay, yeah. I should remember that. It's basic, whatever. Then I'll have the alien X value. I'm just separating these out. Should be at EH. The number of aliens left in play, although maybe we could compare to alien array, so we don't need this as an extra one. But I had it as an extra one, so I'm going to keep it here for now. This will be 2F, so this will be number of aliens still alive. That's a Portal reference. We'll use that. The direction the aliens are moving in, I just called it direction. It'll be, I think, a 1 byte value, right? Yeah. It'll be a 30. So this is kind of, I might give it a better name later, but this is sort of the number of pixels that aliens are going to move in the X direction. So if this number is like 5 on each time the aliens move, I want them to move a positive 5 pixels. If it's -5, they're going to move a -5 pixels or to the left. Since X increases to 320, going to the right, if this is a positive number, they'll move to the right that amount. If it's negative, they'll move to the left that amount. I had a move timer. We're going to set this 2 bytes. So I'm going to be using BP for this later because it's free and it's something we can use it for, the base pointer, since it won't be used for other things. I'll say number of game loops or timer ticks to wait before moving aliens, or before the aliens move. So if we can set this to like 20, and then every 20 game loops, the aliens will move, and we'll have them go slightly faster each time they move down. So we can like decrement this number to make them move slightly faster, say. Or you can increment to make them slower, stuff like that. I called this change alien. That's not a great name, but that's what I called it at the time. But this is going to say basically a 1 byte value. Use alternate sprite. Yes, no. This is kind of a bad way to do this, kind of alternating. But if I want to use the first alien sprite or the second alien sprite every time they move, I'm just going to like change this from a 1 to a 0 or a 1 to a -1 or something. That's what I'm going to use that change alien variable for. I had a couple other ones. All right, let's do the Y values for the player and the barrier. So barrier Y, I did 80. I didn't do it in hex for some reason, but whatever. 85. So it'll be on the 85th row of the screen. Well, the pixel row that we're drawing. So it'll probably be times 2 because we're going to scale everything by 2. Player Y I did a little bit lower at row 93. Okay, the starting barrier X position as well. Since the barriers are going to be static the whole game, we can make the X position a constant as well. And I did 22 for that. And then I also had a couple little ones like sprite height and width. So the height of a sprite is going to be 4 bytes. The width of a sprite is going to be 8 pixels. The width in pixels of a sprite. I think I only use this in one place though, but whatever. Just to be really semantic with it, really pedantic, whatever that word is. The width in pixels is going to be 16, so. Or I don't know, data pixels or something. When we write it on the screen, it's scaled by 2, so it's 2 times the other one. But whatever. I think those are the only, or that's the last, the end of the constants and everything. Okay, if that makes sense. If we want to be super explicit, we can also put bit 16. I guess I'll leave that there. Now that we have all the variables set up, I'm going to store sort of initial values at these places in memory, at these variables. So like along with our sprite bitmaps and everything down here, I'm going to have values set up for all these sort of in order here. So I'm going to put some initial alien array values. That's 2 words or 1 double word, but I'll just put 2 words here. I'll make them all 1s, so all Fs. Let's put that twice. It's going to be the alien array values, the initial values. Initial variable values. There we go. Okay, player X value, I did 70. So 230A, this was... No, I need the shots array. What am I doing? I need that first. That won't be down here. That'll be implicit. We'll load this later. But we'll say, just so I remember to use zeros for this later, I'll put this here. Shots array. This will be alien Y and alien X. So the Y value is going to be read, it's kind of read from right to left because it's stored this way in memory, because Little Endian. So we're using 10 for the initial alien Y value and 35 for the initial alien X value. Then we'll do FB, the direction, so I need the other one. Do 20. The number of aliens we start out with is 32, so I could probably save some bytes by not using this and just checking if the alien array that we filled is 0. So I might change to do that later, but this is how I had it before, so I'll put it as a to-do item. FB is, what is this, -5. If we count it as signed data, this is going to be -5. This is going to be the direction. So the initial movement of the aliens, when I start drawing, they're going to move to the left, 5 pixels at a time. So I'm just setting this initially -5. The move timer. So the initial number of game loops or timer ticks I want to wait before moving the aliens, I'm going to say 18. If you want them to move faster, make it a lower number. If you want them to move slower, make it a higher number. Then the last thing, we'll just do a 1. This is going to be change alien. So I'm going to switch between, or toggle between 1 and -1. And then I can check that value if it's above 0 or not. I guess if it's below 0 or above 0, depending how we want to start it off, we can use the alternate alien sprite so that they sort of move, right? Do the jump and jack things every time they move. So I'll use it for that. So how do we set those up? And these memory addresses up here, well, we can set something to this address and then move the data over. So I'm going to do that. But I'm going to move DI to wherever this stuff starts. So sprites, I'll move sprites into DI. So that way it'll get the address. And then we can set SI or AX to wherever our actual data is down here. I'm going to use SI because we can do like move string, whatever, byte, word, double word, and then SI will automatically increment as well as DI. So we can just move it down the list. If you want to write your code better to where you don't have to do this, that would be good too, but this is how I'm moving the initial data into that area. So SI will point to the bitmaps, and then we can sort of be off to the races here. But okay, the initial sprites, we want to move the alien 1 and 2 bitmaps, and the player ship, what's that, 4, 8, 12. Let's move these 3, so that's 12 bytes. So I can do CL12 and move string byte, or I can do 6 and move string word, and a repeat. And that'll move those into memory. SI and DI will increment. Here in NetWide Assembler and using QEMU and everything, this isn't on real hardware, but we're assuming a couple things. I guess I'll put that up here. Put note, assuming direction flag is clear. So we don't have to mess with setting and clearing the direction flag. SI and DI will increment when, string operations are used. Instead of, if the direction flag was set, they would decrement, but we're assuming it's clear, so they're always going to increment. Also, you'll notice I'm not really going to set up the stack. In QEMU, as I'm doing it, the stack pointer, is initialized to 6EF0, at least on my machine. This is where it's initialized, and BP is set to 0. So I don't have to mess with the stack. On yours, maybe you do. Hopefully not, though, but I'm assuming some things here. That's why I'm saving some bytes by not messing with those things. Okay, so we move the initial sprites into there. Let's move the barrier arrays into there next. So the way I'm going to do that is do load string double word. I want to move the whole 4 bytes of the barrier into AX, right? Well, EAX. This is going to be a 2-byte operand because we're in 16-bit mode. It'll assemble with a size prefix of, I think, 66 hex to say, hey, you're in 16-bit, but you're moving 32-bit values, which you can do, and it's fine. It just takes up more space, so I don't usually like to do it. But we can move that all into EAX, and then we can repeat 5 times and store string double word. We'll do repeat, which I think this will be store string double word would have a size prefix, repeat would be a prefix. So this should be 3 bytes, this will be 2, this will be 2. Not that you're keeping track, just letting you know. Normally, if we did string word, it would be 1 byte less, but we're using a size prefix to use 32-bit values here. So we'll store 5 barriers, 4 barrier array. Okay, and then I'll do set initial variables. So the alien array and the other stuff. So the alien array is 4 bytes. Player X is 1 byte. Alien X and Y is 2 bytes. Number alien is 1 byte. 1 byte for direction, 2 for move timer, 1 for change. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we can probably do that, right? And that would take care of all that? Well, other than the shots array. No, that's true. So let's move the alien array into player X, which would be 5 bytes. And then for the shots array, I'll XOR AX, or 0 out AL, whatever. I know I have to move CL a lot. I'm kind of wasting space here, but this is going to be 6 zeros for the shots. So store string byte, or 3 words. Well, actually 4 words. It's going to be 8. Never mind, I did times 6. It's going to be 4 shots. Let's do 4 words. Repeat, okay. So SI should be pointing to alien Y and X now. So that would be 2 bytes for that, 1 byte for the number of aliens, 1 byte for direction, 2 bytes for the move timer, 1 byte for change alien. So 2, 3, 4, 5, 6, that's 7. CL7 and repeat move string byte. Okay. That should be all right. So that should be all the initial variable setup that we need. So then if we want to use SI and DI and want them to point to the same areas in memory so that we can both use, you know, the data segment and the extra segment, use SI and DI, string operations, all pointing to this area, we have to make the data segment and the extra segment equal. To set DS equal to ES, in 2 bytes, I'm just going to push ES and pop into DS. Instead of moving into AX as an intermediate value, we can just push and pop. Each of these are 1 byte. Opcodes, so it's good. Okay, we can actually get to drawing the aliens, you know, here. So we start off with, you know, 32 ones set in our alien array, 32 aliens we want to draw. We can go ahead and do that. SI is going to be pointing after here. So we can either subtract a value to point all the way back up here or just move it into SI. So let's move alien array into here. This is one way of doing this. The whole game here really is just one way of doing this. Hopefully it's a decent way, but you can always optimize things, you know, a lot better than I have. I'll emphasize that. This is not the best way by any means. It's just a way to do it. So the best and worst thing about programming is that there's always 10,000 ways to do anything. And this is, you know, one of those 10,000. I'm going to be using BL for the color value that I'm going to use later inside of like draw sprite. So we'll do that. The alien Y and X values, the initial alien Y and X values, I'm going to move into AX. So that is data at, one way to save a byte here and there is if you take the data at the address like alien Y, this will use, you know, more bytes because we're getting it from memory first and we're doing that. We got to reach out into RAM, see this address, and then get the data at that address. Takes more cycles, takes more bytes for the instruction. If you use or offset from a register, it'll be less bytes. So if you use this multiple times, then it's good. If you only do this once, every once in a blue moon, it's fine. But if you do this multiple times, it's better to use like a register value that'll save bytes, because it doesn't have to reach out into memory to get the address. It already has it within the CPU in a register. So kind of that makes sense. But even so, you can offset a value from that register. And as long as you do this multiple times, instead of just, you know, the alien Y value, it'll still save a byte here and there. So that's what I'm going to do for a lot of this. I want to get the alien Y value offset from, we'll say, the alien array. So this is at FA32. And alien Y is at 2D, which is 32 plus 13, which is 45. So 45 minus 32 is 13, right? So we should be able to do SI plus 13, I would think. Alien Y X. So this will be AL is alien Y, AH equals alien X. And then I'm going to see if we want to use the change alien sprite, yes or no. So this is at 33, so this is 48 plus 3, so that's 51, right? Alien array's at 32, so 51 minus 32 is 19. So we'll see if that works. And if I don't do any of this right, you'll see when we go to draw it on the screen, it'll all be not right. So I'll have to change it and debug it. But right now, let's assume this is all correct. Okay. I'm going to compare this to CL. So I want to compare this to 0, but since we're guaranteed after this repeat here that CL is 0, you can save a byte by comparing to CL. So that's what I'm doing. Compare to CL, CL equals 0. If it's above 0, I'm going to say we're just going to draw the regular one. So I'm going to go to, I guess, draw alien loop or something. We'll have a loop and draw them here. Nope, use normal sprite. Otherwise, it'll be yes. Okay. So I did this. Okay, yeah. Yes, use alternate sprite. So we have the alien 1 and 2 sprites in memory. They're 4 bytes each. So this alien 2 is offset 4 bytes from the first one. So if we want to use the second one instead of the first one, we'll add 4 bytes. Okay. So if we do a move CL4 here, we can just add CX to DI, which will save a byte compared to adding 4, since DI is a word value. So the 4 will be cast to a word, which is 2 bytes. So to save 1 byte, we can use CX, if that makes sense. And we have to use a byte value to add to DI anyway, or a word value to add to DI anyway, so might as well do that. If we move CL4 here, this does not affect the register flags, the flags register within the CPU from this comparison. So we're comparing to 0. The 0 flag will be set, for example, but this move here does not affect the 0 flag, so we can use it in this comparison and then just add CX, which will now be equal to 4, to move to the next sprite. Whatever, trying to save space wherever I can. But okay, we have the sprite we want to draw. It is in DI, but we need to check if we need to draw the alien or not according to the alien array values. If it's a 1, we're going to draw the alien. If it's a 0, I'm not going to draw it. We, already got rid of it. So I'm going to save everything first. Eventually we'll pop it back out somewhere along down here. Save all the registers, pop them back. You can do this to save and restore multiple register values with only 1 byte. This is a 1 byte operand. That's one way of doing that. If you have like push SI, push CX, yada, 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 you can do that all at once with a push A and a pop A, but it does affect, the other general registers as well. So you have to keep that in mind. So I'm going to push everything. Let's move CL8. So for the current row, we're going to have 4 rows of 8 aliens, right? So this is going to be number of aliens to check per row. Then we'll have like the next row we're going to check. I'll have a little loop thing going on. Within that row, I'm going to save and restore stuff as well. So I'm going to use bit test here. So I'm going to decrement and we're going to test if the data at SI. So if the bit in the alien array, the CX bit rather, is set, then it's 1, and we're going to draw that alien. If the bit in the array is cleared or not set, it's a 0, then we're not going to draw that alien, because the array is basically 32 ones to start off with. So if we, later on when we hit an alien, we're going to clear the bit. If we reach that 0, we don't want to draw that one. We're going to skip over it. And that's what this check is doing. BT is bit test, and it will copy the bit referenced in this operand to the carry flag. So bit test is also 0-based indexing instead of 1-based. So to reference bit 7, or 8 to start off with, if we have 1 to 8, it's actually 0 to 7. So the most significant bit is 7 instead of 8. That's with 0-based, we have to decrement CX first. That's, that explanation. So basically the first time we do this check is bit 7 set. Is the first alien in this 8-bit array, is it going to be, do we want to draw it? That's all that's doing. But it copies it to the carry flag. If it is not set, we don't want to draw it. So I'll have like some other label here, go to the next one. Not set, skip. If it is set, we want to draw it. So what I'm going to do for that is move DI into SI. Right now in this loop, DI is pointing to the alien we want to draw, either the first one or the second sprite, according to which one we're drawing. And I'm going to set up draw sprite to use SI as the data that we're going to draw. That's why I'm moving it into SI right now. But SI is the sprite to draw. We're going to call and actually draw that sprite. Otherwise, well, after we draw it and the next time we do it, when we get to the next alien, we're going to pop everything back out, so DI will once again, SI will once again point to the array, not this sprite we're going to draw. And to get to the next position for the next alien I'm going to draw, since I moved alien X into AH initially up here, I'm going to add a sort of offset to draw the next alien at, an X offset. I can use it in terms of the width of the sprite, so if the width is 8, we want to draw it at least 8 pixels over, or else it'll overlap and look weird. So if we draw it 8 pixels over perfectly, then they'll all be like one line connected. If we want a little bit of separation between there, we can add pixels in between. So I'll add like 4. So really this number is 12, but we kind of want to offset 4 pixels between each alien to give some space for it to look better. Okay, but after we get the next one, we can loop back to the next row and get the next row. So, well, actually this is kind of the current row, isn't it? This sort of draw alien loop is the next row. Let's do... I guess draw next alien, or does that make more sense? Because this is the next one to check. So let's do check next. I want to make this easier to understand, right? No confusion. So we'll check the next one. Is that bit set? We'll draw it. If it's not set, we'll go on. We'll check the next one. Okay, that makes more sense. After we move through and check all 8 in the current row, we want to go to the next row. So I'll pop everything back out. That was set above here before CL was 8. So after we draw all the aliens offset by X values in the current row, we want to go to the next one. We're going to add a Y offset to draw them down below the first row, right? So since we have the Y value in AL, I'm going to add an offset to AL. And we can offset from the height of the sprite, which is 4 over here, right here. Width is 8, height is 4, so I can add 8 plus 2 or 4 or whatever. I think 8 plus 2 and then, or 8 plus 4 and then 4 plus 2. This looked decent, so that's what I ended up using. And then we can loop back again to the draw loop, the overall loop. So draw next alien row. Okay, and this will end up drawing, well, 4, this is set to 4. This will end up drawing 4 rows of 8, according to if the bit is set or not in the alien array. So I know we did all that and we haven't really done anything yet, but that's sort of a setup for drawing stuff. The aliens specifically, I'll get rid of that to do, and I'll put in the draw sprite. That's English, and then we'll draw the thing. So we'll fill out the draw sprite. This draw sprite will draw the aliens up. Draw sprite is going to expect some certain inputs, so I'm going to put those here. Input, not, I guess you could think of them as parameters. So I'll put input parameters. They're going to be in registers. We're going to assume SI is pointing to the sprite to draw, or the address specifically. Address of sprite to draw. AL is going to be the Y value of sprite. AH is going to be the X value of the sprite. and BL is going to be the color to draw the pixel for the sprite. And the first thing we do in here is call get screen position, so we'll have to fill that out, but that's okay. So maybe I'll fill that out first. We'll fill out these two things. Okay, the input for the get screen position is just going to be the X and Y value we want to draw at, so it's going to be an AX, so the same as above. AL equals Y value. AH will be the X value. So I can also put, I guess I'll put this. It's going to clobber dx, so just keep that in mind. Dx will be, you know, not the same as it was going in, because I'm not doing pushing and popping to save bytes. So first of all, I'm going to move AX into dx just to save off, save Y X values. Okay, and then since we have the benefit of the Y value always being an AL, and also since I'm going to be scaling the pixels by 2 on the screen to draw at, the Y values that we're going to be dealing with are only going to be 0 to 100. The whole height of the screen is 200 pixels. We're scaling by 2, so we can divide that by 2 before we scale it. So the Y value is 0 to 100. The reason for that is that we can do things like convert byte word, the CBW operand here, which will sign extend AL into AH. So if AL is below like 128, so the top bit isn't set for binary. If this top bit is set, that's like 80 in hex or 128. So this top bit is set in binary, right? This is, yeah, one byte. So if AL was 128 and we did CBW, this would be sign extended into AH. So the 1 would be copied into AH and we'd end up with like that effectively. Well, this would be set to 1, but yeah. We don't want that. I want to like calculate the X position and the Y position separately, but also using AX to put into DI, we need a word value. So we're using AX here. So basically I want the top to be cleared at this point so we get a valid Y value. So if we sign extend and this bit is not set in AL, we will extend the 0 to AH and it would just be, you know, a bunch of zeros. That's why I'm doing that. So effectively AH equals 0 if AL is less than 128. I'm using this because CBW is a 1 byte instruction. So instead of doing move AH0, which is 2 bytes, CBW is 1 byte, saves a byte. Let's get the Y value into DI first. I'm going to use signed multiplication instead of unsigned because imul has a 3 operand form, whereas mul does not. So into DI, I'm going to put our AX, our Y value, since we did CBW, multiplied by however far into the screen we want to draw at. So I'm going to be scaling by 2, but each row of the screen in pixels is going to be like screen width in length. So we want to go this many rows down the screen, and then also we're scaling it by 2. So multiplying the Y value by this amount to go down into the screen where we want to draw our pixel at. Well, our sprite at. We're going to start drawing the sprite at this pixel. So DI equals Y value. So now that we have the Y value, we're going to add the X value to that. And I'm going to move DH into AL. At this point, AH should still be 0. So AX will equal the X value. I can shift left AX by 1. AX times 2. We're going to multiply the X value by 2 because we're scaling by 2. And then we can add that to DI. Y value plus X value or XY position. And then we'll return. X value times 2, shift left, shifting left by 1 bit, multiplies by 2. The reason I'm not doing AL is because the X value could be above 128. Since I'm scaling by 2 and our width is 320, it could be 0 to 160. So if we're all the way on the right side of the screen, it could be above 128. Shifting left AL would shift into AH. So I just want to do AX so it, you know, works. Well, actually, I don't think that'll shift into AH. I think it'll just put a 0. So I want to ensure that it goes into AH if needed. So I'm using the whole AX. But this does use an extra byte, I think, because this 1 would be cast to a word value. But that'll get the screen position in DI. So to actually draw the sprite, we'll fill out this routine. To start off, I'm going to move the heights of the sprites into CL. We're going to draw this many rows of the sprite, right, on the screen. So I'm going to draw left to right, top to bottom, to draw the sprite. But it'll be similar to our draw alien loop that we had above. I'm going to have a row for each well, not alien, next row of the sprite we want to draw. Next line, next row. I'm going to save off CX and we'll pop it back later. Okay, but to get the initial data, we need to check to draw, and then each additional line of the sprite. Since the sprites are 4 bytes in memory, and SI is pointing to that memory, we can load a byte from that location. And then SI will automatically increment to the next byte from the load string byte. So that's good. I can save off the value by doing an exchange. So save off sprite data. Just to have a temporary storage space again, I should do this again. Clobbers dx. So the reason I'm doing an exchange and not a move is because I'm going to move other values into AX to later draw to the screen. Otherwise, if I wanted it just to be copied, I could do a move. But if I don't care what the value of AX is going to be, I just want to save it off, I can do an exchange. And what this will do is swap DX and AX, but also be a 1 byte operand. A move AX into DX is 2 bytes, but an exchange with AX or with EAX, if you want to use 32-bit, is going to be 1 byte. So if you exchange with the accumulator, it's 1 byte. It saves some stuff. If you need to save off values or move them back and forth, that's a good way to do it. But okay, after we did that, I'm going to move 8 into CL. And the number of pixels to draw, we can make this sprite width actually. Sprite width. Number of pixels to draw. And then we can have a next pixel loop here as well. And here, since don't care about what AX is going to be, I'm just XORing it anyway. If drawing blank, black pixel. So if the bit is, I'm going to check the bit again with the bit test thing. If it is set, I'm going to draw the color, but if it's not set, I'm just going to draw a black pixel. So I'm XORing this to begin with, so I don't have to mess with it later. It's already set. To do a bit test, it's 0 base, so we have to decrement again. And then I'm going to bit test DX with the CX value. We could do something similar to the alien loop where we do like a jump grader if it's set, or set it and then go on. Here, it ended up being the same amount of bytes to do the compare and move, and it takes up a couple or 1 or 2 less lines of code. So to save lines of code, I'm doing a CMove here. So CMove grader, I'm assuming BL equals the color. So I'm going to move BX into, or well, yeah, I'm going to move BX into AX if the bit is set, which is copied to the carry flag. So compare and move, if the carry is set, BX into AX. If the carry is set, BX will be moved into AX. If the carry is not set, then AX will still be its previous value, in this case, 0. So if the bit is set in the sprite, we want to draw the color for the sprite, which we're assuming BL will equal. I'm moving that into AL effectively. The compare and move needs word-sized operands, otherwise I would be using BL and AL. But it needs full words, so BX and AX. Okay, and then to copy the color, just to ensure that it works, I'm moving AH into AL. So copy color to fill out AX. And then to draw each pixel on the screen for the sprites, I'm scaling by 2. I'm going to draw basically a 2 by 2 square for each pixel, so it's easier to see. If it's just 1 pixel, it's kind of hard to see. But if I draw 2 and then 2, then it's, you know, a box of 4 pixels. It's easier to see than just 1. So to do that, to draw the 2 by 2, one way of doing it that I think Oscar Toledo did that I kind of am copying here is to move into the position at DI plus the screen width. So the position below one row below in the screen that we're currently at, I'm putting 2 pixels into there by drawing 2 bytes and AX, you know, to that position. And then to draw the current row where we're currently pointing to, I can do store string word. So this is drawing 1 row below where we're at and where we're at. So on the screen, we would draw like, you know, this. We're starting here, DI points here, but we're drawing this first and then this. So then when we do store string word, DI will increment by 2 and it will point to the next pixel position, right? I don't know, it doesn't matter. Data here, we would draw these 2 pixels, these 2, and then store string word, DI would be pointing here now because it increments from here by 2. We draw these 2 and then these 2, it would increment. So we're drawing the 4 pixels at a time for each single pixel specified. if we did not draw the last pixel in this sprite row we're currently at, then CL from this decrement will not be 0. So these moves right here, this compare and move, these moves, these do not affect the 0 flag. The bit test affects the carry flag, of course, but it does not affect the 0 flag. So we can use the 0 flag result from this decrement to see if we still have pixels to draw in the current row. So I can do jump not 0, next pixel. And that way we don't have to do like a loop, because that would take one more byte. A jump not 0 takes one less byte than, you know, we're already decrementing, which the loop will do anyway. We can just do this. Okay, but if we did draw the current row of 8 pixels, we want to go to the next row. To get down to the next row on the screen we need to draw at, we need to offset DI to that position. So I'm going to add the screen width to go down one row on the screen, multiply by 2 because I'm scaling each pixel by 2, and since we just drew a 2 by 2 box, we need to go down 2 to get to the next position in the Y axis for the next pixel. And then I'm subtracting the pixels that we did draw on the screen. So sprite width in pixels, which is 16 right now, but since we drew the pixels across, 16 pixels across, 8 multiplied by 2, when we're moving down in the screen, we need to move back the 16 pixels to line up the next sprite line. So it'll draw 8, 16 pixels, go back to the next row, draw 8, 16 pixels, go back to the next row. You know, it'll do that until the sprite's done. However much sprite H is, which is 4. But that's why we're doing this for the next row. We're offsetting down to there. Okay, then I'm going to pop CX and I'll do the normal loop here. Loop next line. Yeah. Put it there so it lines up. So then we'll draw the next the next byte of the sprite. We'll push the CX value, we'll load the next byte, exchange it, you know, we'll compare, we'll draw it. This will draw the sprite on the screen. At the X and Y position, we have set an AX with the BL color, SI set to the address. So for the aliens, for example, if we do choose to draw it, BL will be set to the color, AX is going to be the Y or X, which is offset by whatever position we're at. DI is going to be the position that we got from this call, so I think we're all good. I should probably put DI for clobbers, because these do mess with DI. Okay, assuming I did things reasonably correctly, if we go to draw, we should get the 4 rows of aliens on the screen. If it doesn't work, then I did something terribly wrong, which is why I have all these errors here. Symbols are undefined. Next chain, draw alien loop is undefined. Yes. If you get one thing that's undefined, then everything following it will also be undefined because it didn't set the address right. So this will be draw next alien row. Of course, that is the correct name for it. Okay, screen width is undefined. Is it? I thought I did it up here. Oh, I set screen width, not screen W. Yeah. I made them actual full names to make more sense, didn't I? Yeah. Okay, that's okay. Do screen width there. Or sprite width. No, I did sprite height and width. Let's make this consistent. I'll do px for pixels. Put this. Okay, is that not correct? It's not. Where do I have this stuff here? Okay, let's do it the nuclear option. Sprite width. And we'll change it everywhere. So everywhere. Want to substitute H with sprite height everywhere on the line. There we go. And I want to do the same for the screen width. Do I have screen height? H, no. Right with pixels undefined, no it's not. Oh, it is. Okay. There we go. Just for a little catch up here, this is how much we are currently taking up. This is how much that's available. These many zeros here. So we're still doing all right, not even at, we might be at like 40% filled, and that's okay. We got a lot of underlying drawing logic out of the way. Let's see what it looks like. And it's blank. Well, that's good. This is one issue, probably not what we're dealing with though. It might be that these are not right offsets and stuff. At least for this timer here, since we set these equal, and the timer in the data area is going to be 046C, that's offset from 0, not from wherever DS is currently pointing to. So one way we can get around that is saying, like I did down here, I said this was code segment data, so technically the timer is in the code segment now, which is offset from 0, so we can put a prefix here for that segment, and that will work now, although something might not still be drawn because some other error came up, but this will at least get the timer right, so that movement can happen later. But it's still that way. Okay, I'm going to debug, and we'll see why it's doing that. Okay, I found a couple of small issues here. I fixed them. To get to the next, can I like press enter? There we go. To get to the next row that we want to draw at, we need the next byte from the array here. Right? To get to the next byte, it's going to be 4 bytes, right? For 4 rows of 8. To get to the next byte each time, I need to increment SI before we go and draw the next row. Otherwise, SI is pointing to the current row. Right now, that's okay, but when we actually start to, get rid of them as we shoot them, we need to get the correct row we're actually checking. So I need to increment here to get to the correct byte in the array that is checked at this bit test line here. Okay, so that's one thing there. Make sure you had an increment. The next one is down in draw sprite. I had move AH to AL. That is not correct because BH could be something like garbage, whatever here. I need to move AL into AH to correctly copy the color over so that we can do this store here and this AH move here. Okay, and then the last thing was down here and get screen position. I had move AL to DH. I need to move DH to AL because that is the saved off X value from this. We're using the Y, then we need the X. We need to get the saved off X and DH, not the opposite here. That was not correct. Okay, and that was all that changed. Those 3 little typos mistakes there. So with those fixed, now we get to draw. Hey, there we go. So we got the first one here. We have them separated out by some manner of space, and then in the X direction and in the Y, and it draws the pixel. If it's 0, it doesn't, or it draws like black right now. So we have the array here. That's pretty cool. But I'll get on to moving to drawing the barriers down here, then the player, and then we'll get some movement going, and yeah, so almost exciting. Not quite, but almost. Okay, hey, let's continue on with this. I'm going to probably draw the player ship and the barriers next, now that we have the aliens drawn and working all right now. This is how much space we currently take up. Let's go and do that. So we just drew the aliens. We used the alien array for that. So after our current code here, SI was set to the alien array right up here. So after this is done, SI has been incremented like 4 times for each row. So SI will now point to player X after this point. So I just moved the to-do for the player ship above the barriers so we can, take advantage of how the memory is currently laid out here. So we'll do that. Okay, so if SI is currently pointing to player X, that thing up there, I guess I'll keep this up. SI is currently pointing to this over here. And that is a 1 byte value. We can do load string byte. So that way AL equals the player X value. And then if we want to draw the ship though, we need the sprite to be up here. So currently after the load string byte, SI would point to the shots array. But what I'm going to do is push SI and then we'll pop it out later after we're finished drawing things. To bring it back to the shots array. But right now we'll push it after we loaded this. So SI points to the shot array. I'm going to draw the ship. So I'm going to move ship to SI. We do need the player Y value as well though, so let's move that into AH. Player X is an AL, so now if we do this, player Y, which over here is 93, that's going to be an AH. I kind of want to swap those, because in draw sprite, I'm assuming AL is player Y and AH is player X. So I can do that simply enough with an exchange. I can just exchange AL and AH. It can be in either order, so that'll just swap them. So swap player X and player Y values. SI is pointing to, you know, the sprite we're going to draw. We do need the color, so I'll move player color into BL. Okay, so what else do we need? I think that's all we need, yeah, and it clobbers these two. Okay, so we can do that. We can call draw sprite. That should draw the player in like approximately the middle of the screen according to the initial player X and Y values. Just do a simple make, do the make run again, and there we go. We got the little player ship down there. It's gray. It's there approximately in the middle. It can't move yet. We don't have input, but there you go. I guess to get the last thing on the screen other than the shots, well, that'll be the barriers. So let's go ahead and draw those. But okay. I'll probably pop SI after the barriers though, because we'll need those for the shots. We'll use that after this. Let's draw the barriers before we do that. So if we move to ship to SI, inside of draw sprite, we do a load string byte. This is going to be approximately 4 because our sprite height is currently set to 4, right? So load string byte will happen 4 times within the draw sprite sort of subroutine here. So that means SI will be incremented 4 times for each line of the sprite. So since each sprite is 4 bytes, and if SI starts on ship, after draw sprite, it's incremented 4 times, it'll be pointing to the barrier array. So we don't have to add or do anything to get to there. SI is already pointing to the first barrier in the 5 barrier array. We need a different color for the barriers, so let's set that up. Do barrier color before I forget. And we need the X and Y values. So what I can do is move those probably both into AX. I do have them separated out right now. I could just make either this barrier X and Y, I could just make this like one word. Maybe I'll do that, that would be easier. Let's do that. I'll call it barrier XY, and it'll be 8522. It would have to be, that's just the, or 2285, sorry. Gotta swap them around because a little Indian. So 22 is going to be the X value, 85 is going to be the Y value, just so I can load a word into AX to use within draw sprite for this instance. You know, the constant here. Load barrier XY into there. What are these values inside hexadecimal? Because this won't work if we just try to load the integer things. That won't work. So I need to add 4. Let me just use a calculator. I don't need to do this. It's too early in the day. I only had 1 cup of coffee, man. Give me a break. 16. Okay, in hex. So 16 and then 85. So I think it's 55 in hex. Yeah, because 5 times 16 is 80 plus 5. Okay. So 16, 55H. That's what we'll use here. And that'll be moved into there. Okay, so then we need SI. SI is pointing to the first barrier. That's okay. I will have to do like a CX thing though, I think. Let's do this, because I'm going to be drawing 5 barriers. Let's move CX5. We can push and pop it after and make like a loop. So let's do draw barrier loop, pop it, and then loop to draw barrier loop. So loop will, you know, decrement CX and then jump back if it's not 0. So we'll do that. I'll put this on the inside, just so I don't forget when we do the pop SI here, it'll point to shots array. We do want to mess with AX values though. We don't want all the barriers to put, you know, be overlapped on top of one another. We want to, you know, offset at least on the X axis for each barrier to space them out on the screen, right? So to do that, instead of the push and pop CX, I think I'll do push and pop A just to have more, you know, everything else be there. And then what we can do is add, this is kind of inefficient, but we can add the sprite height to SI to move to the next barrier within the array, right? We can do that. And then to add an X offset between each one, we can add to AH for the X value, however much we want to space these out. I think I did 25. Yeah, I did 25 before. This will be the number of pixels, be x pixels between barriers. So they'll be spaced out about 25 pixels apart. There'll be 5 of them. I just need to call draw sprite in here. And that should handle drawing the 5 barriers. But now that I'm looking at it, it probably would be better to move the barrier drawing like right after, or the first thing we draw. So then we could draw this and then move on to the alien and then draw the player. And then it might be better laid out if I did that. Maybe that'll be like a to-do later. Or that's something you can mess with, I don't know. That might be better and save some bytes. I'll put that there to look at later. Could save bytes. Okay, I'll just put that there. But we'll see if this actually draws the barriers. It should draw 1, and then move everything back to how it was, add an offset to the x value, move to the next barrier in the array by adding this, and then go on again. So hopefully that'll work. And it did. Okay, cool. We got the 5 barriers there. 1, 2, 3, 4, 5. So each, starting x pixel over here, well, it'll be the top left, but each starting x pixel is going to be 25 away from the previous one. And that kind of spaces it out all right. I think it's a little shorter on the left than the right side. So if you have like super OCD, I apologize. It's not exactly lined up, but it's close enough. Okay, and then we can draw the shots or check if they hit anything. If they didn't hit anything, we can draw them. We can create the alien ones. I'll just put some spaces here. Okay. So let's move on to check the shots and see if they hit stuff. Although we haven't made any yet, but that'll come into play afterwards. Okay, let's go on and check if anything in the shots array, if we have valid shot values here, valid x, y, yx values, if that corresponds with hitting the player, the barrier, the alien, or nothing, the background, I guess, and then we can just draw the shot where it is. Okay, so if we have 4 shots here, I'm assuming we're going to have 4 shots. I'm going to loop through each of those and see. So I'm going to have, kind of loop there. I'm going to move CL4. This is how many shots we have, so I'll loop through them, do like next shot or something. Maybe get next shot. And we'll loop to there until we're done. But for each shot in the array that SI starts out pointing to, it'll be a Y and an X value. So if we do something like load string byte or load string word, we'll get the Y value and we can check. So what I'm going to do is load string word. I'm going to get Y, X value, values for shot and AL, AH. And then we can compare if AL is 0. So I'm counting if AL is 0, I'm saying the shot's Y value is 0. It's sort of not in play. It's kind of like reset, or it's in, I don't know. It's not really going to be on the screen. I'm going to not draw it. I'm just going to skip over it. So I don't have to worry about anything. If the Y value is 0, if it passes over like the top of the screen for the player shot, the Y value is going to be 0. We don't want to mess with it anymore until we make a new shot. Y value 0, skip shots. If it's not 0, I'm probably going to go and check the shot. So I'll go to check. I'll make a thing down here. Check shot. But if it is 0, then we want to, get the next one. So we can loop. I probably will be messing with CL and this stuff down here, though. At least I did before. So I am going to add a push and pop CX here. We jump not 0. Otherwise, we pop CX and loop back. Next shot. This will come into play in a bit, but I had a thing called next shot here so that if we don't hit anything down here, but we still need to like skip or go to the next shot, I can jump back to this point and then it'll go back to this loop and get the next shot, right? So that'll come into play later. Right now that's a little confusing because it doesn't mean anything, but if we did not, or we skipped over, or we checked and drew all the shots after we get all the way through this loop, we do want to go on down to somewhere down here. So I'm going to put that here so I don't forget. I had it as going to create alien shots, which will be down here. So when we've gone through and drawing, or not drawing, and checking all the shots, we'll go down to do this. If we're going to draw it, it'll end up down here, right? If we're not drawing it, it'll go to the next one. But when we're done going through the whole shots array, I'm going to go down and create the alien one. So trying to keep 3 things in my head at the same time and explain it badly. It's kind of hard to do. That's okay. If we have the Y and X values inside of AX at this point, and the Y value is not 0, those are still within AX at this point for the current shot we're on. So what we can do is get the position of that with get screen position. So that'll put the shot's XY or YX position in DI, so we can check the byte that DI is currently pointing to. We can check, you know, what that value is, which will be what the color on the screen is for that pixel. So if we're moving our shot and it's currently on like the color for the alien, which is green, and we're on like the player shot, we'll say, I'm probably going to assume the first shot and this is the player shot. So let's do that. I'll put that down. First shot is player. Others, you know, others are alien shots, but the first shot is going to be the player one. So we get the screen position in DI. We can check the color of that byte to see if we hit anything. So I'm going to move that into AL, because if we do compare bytes at DI, that takes up a lot more bytes than just doing compare AL to something, you know. Compare byte DI to X takes up a few more bytes than compare AL to X. And we're going to be doing this comparison at least 3 times here. So it saves more bytes overall if we first move it into a register like the accumulator here. Okay, so what I can do is see if we hit the player. We just have to compare AL to the player color, pretty much. And if it did hit the player, then they're equal, and we'll go to game over. We'll say, hey, this is going to be an alien shot. So the player shot, I'm going to spawn probably like right above the player sprite. So it will never, the player shot will never equal the player color. So we don't have to worry about that. We can just have one general comparison here. If whatever shot we're on hit the player, then it's game over. These will just be the alien shots. Okay, and that's simple enough. That's really all we have to do for that comparison. Otherwise, we can check if we hit the barrier. So I'll do the similar comparison, compare AL to the barrier color, so either the player or the alien shot can hit the barrier. We'll eventually erase the pixel there to kind of destroy that part of the barrier that was hit. But we can check if we hit it. If we did not hit it, then we'll check if we hit the alien, which will be down here. Can make it a dot even. It can be with check shot. Okay, but if we did hit the barrier, we do want to sort of loop through each barrier and see which one we hit. So I'm going to put that here. I'm going to move where the barrier array starts. I'm going to move into BX, which you'll see in a minute. Before I do that, I need to XOR it though. So I'm going to XOR BX up here because I can use it in more places. To use in multiple places, you'll see it come up. It'll come up in each of these loops that we're checking. I'm going to use BX as a sort of index to whatever current barrier or current alien we're checking that we hit. So if I set it to 0 once, I don't have to reset it to 0 each time we use it in a loop later. So that kind of saves a few bytes there. At first barrier, and then into AH for the X value, I moved barrier X. Well, I have barrier XY. Let's separate these out. I should never have removed it, right? I should just keep all of these here. So barrier XY and barrier X and barrier Y. So X will be 16, Y will be 55. There we go. Okay, so barrier X plus, what did I move? Sprite width? Okay. So start checking at right side of sprite. So what this does is check the X value on the basically the right side of the barrier sprite. If the sprite starts at barrier X, which is 22, right? The right side of the barrier sprite, the first one, would be the X value 22 plus the width of the sprite, which is 8. So this will be effectively 30. So I'm doing this because I'm going to loop through and see if the value is less than or equal to whatever sprite we're on. At this point, we know we hit a barrier, so we know we're at one of those, but you need to find out which one you hit. So I'm checking, basically I'll check if the position we hit is less than or equal to this current sprite we're checking. And if it is, then we hit that barrier. Otherwise, I'm going to add sort of the gap between the barriers, the 25 pixels, and then we'll check again. Since we did the get screen position right here for check shot, when we go down to get the screen position, we're saving off the YX value in AX into DX. So we can use the DX, XY values here inside of our comparisons down here because we haven't messed with DX in the other functions or anything at this point. DH at this point is pointing to the X value and DL is pointing to the Y value. Just keep that in mind because I'm going to have a loop here that we check through each barrier. So Call it check barrier loop, which reminds me of Great Barrier Reef, but it's not the same. Then what I can do within that is check which barrier we're currently on, if we hit it or not. So DH would be the current X value saved off from get screen position, that call. So I can compare that to our current AH. So is the X value of the shot that we're checking, does it equal one of the X values within the current barrier we're checking? If so, the X value is within the barrier, we hit that barrier. If not, we need to go on and check the next one. But if it did hit that one, then this would be kind of true. It would be less than or equal to the right side of the current barrier, right? So less than or equal. Then we would go on and erase that part. If it's not less than or equal, it's greater than the barrier, then it could be in the next one. We need to check the next one. So I'm going to do an unsigned comparison for the jump after, and we'll go on to check the next one. So I'll do next barrier. I'll have that down here somewhere. The next barrier is going to add the offset between the barriers, which is 25. And then to get to the next barrier in the array that we're checking with BX, I'm going to add 4 to BL, or sprite height, I guess could be the same thing, but go to next barrier in array. Okay. Add offset, this will be X, add X offset to check next barrier. So the first one we're checking is going to be the right side of the first barrier. If we're not in that one, to go to the next one, we're going to check the right side of the next barrier. And if we're less than or equal to that, then we hit that one. If not, we'll go to the next, check the right side of the next barrier by adding this X offset each time. After we get the next one to check, I'm just going to jump back to check barrier loop here. Okay, so if we hit that barrier, we need to do a few things. I want to get the start of the X value, so I'm going to subtract off the sprite width, even though we added it up here. I'm going to subtract it off to get starting X value of the barrier. And I'm going to subtract that from the shot. So subtract from shot X. And what this will do, we'll get an offset into the sprite, into the memory, because it's 4 bytes of 8 pixels. This will get the X value as an offset into the sprite to determine which pixel we want to remove on the screen to erase it. Okay, then I had to push A. Then I'm going to do the same thing for the Y value to get the offset for the Y into the sprite so we can get the correct XY offset in the barrier for the pixel we need to erase. That's what I'm basically setting up here. So DH was the saved off X value from get screen position. DL is the saved off Y value. We'll do the same. For the Y, I'm going to subtract barrier Y. So subtract from shot Y. And I'm going to add that to BL. So BX now points to pixel row of barrier. So since we set up BX as barrier array, each barrier is 4 bytes. Since we found the X value that we're going into that, that's good. For the Y value, since BL will point to the start of the barrier, if we add the Y value offset into the current sprite, the barrier sprite that we hit, that'll be the current byte of the sprite in memory. So if we have this barrier right here and we hit like the second row, like this pixel, for the Y offset we're getting right now, I'm subtracting the shot from the barrier Y, which starts here. The shot Y would be here, so it would be 1, right? So we would add that 1 to BL, which would point to the start of the barrier, and it would point to this row here. So that's what I'm doing right here. I'm getting the pixel row that we actually hit. Okay, and then to offset and get the right X value for the pixel we want to do, I'm going to use bit test or a bit test and reset. So the bit test is 0-based indexing. So 0 to 7 instead of 1 to 8. So I'm going to move 7 to AL. I'm going to subtract the X value from 7. So subtract from AL DH, X value from max bit. And then I'm going to do convert byte word because this is going to be guaranteed to be below 128. So we can X out the 0 out the X value. And I can do a bit test and reset on the array. Okay, so we can do a BTR, which is a bit test and reset. And what this will do is the same thing as the bit test. It'll copy that bit we're checking to the carry flag, but it will also clear the bit within this memory location. So if we subtract the x value from the maximum most significant bit number, 0 to 7, this is 7. I'm offsetting from 7 here because this is 7 down to 0. So now that I got the right pixel row in the barrier, if I offset where the x value is, we would subtract that from 7, so 654, it would be there, and then we're going to reset or clear this bit within memory. So this will set the 1 to a 0, and then when we draw it on the next game loop, that'll be the background color. So it'll act like we got rid of that part of the barrier and destroyed it. Bit test and resets, clear bit in barrier. Since our shot hit something and we hit it and cleared it, I'm going to reset the value for y, the y value for the shot, so that we don't keep drawing it. We already hit something. Get rid of the shot. So I'll reset it. So currently where y is, or where SI would be at this point, is after the first, or after whatever shot we're on, because we did load string word within check shot up here. So if y started on the first one, after the load string word, we'd be pointing to the second shot yx. But we're checking the previous one, right? So we'd have to subtract 2 to get the y value of the previous shot that we were on when we did the load string word over here. It's a little confusing. So that's what I'm doing here. I'm moving a 0 into that point. And also, since we did the convert byte word up here, AH is going to be 0. So I can move AH into there to save a byte as compared to moving a 0. Reset shot Y value to 0. Okay, but now that we did that, I can restore from the push and pop A right here. And we can go to the next shot. Where's check shot again? Here. So now that we hit something, we reset the shot. We can go back to the next shot by just jumping back up here. CX was pushed, it'll be popped back, we'll loop to get the next one. But this is what we do to check if we hit the barrier. I know we haven't drawn any shots on the screen, but that should work for hit detection on the barriers, hopefully. Okay, before I do anything else, I'm going to see if it assembles to see if I have any issues. I don't yet. And I want to see how much more space we have to work with. We're a little bit over half, but we still got plenty of room. Okay, let's just see if everything still draws. Everything's still drawn on the screen, all right. Just need a couple sanity checks there. Before I go and check if we hit the alien or create the shots, I'm gonna take player input right now so that we can move and shoot to see if the barrier hit works, stuff like that. So to get player input, let's make a thing here called get input. We can skip down to this label from up here later if we need to. But to get the player input, we have the player X value, right? I don't know where SI is at this point. I'm just gonna move player X into there. So that'd be wherever this is up here. And what I'm going to do to get the player input is slightly different from what I did in the last two Bootsector games. Instead of just getting a key with int16h and AH0, that'll get a key, or AH1 will check if a key was pressed, I'm going to use AH2 to get the keyboard flags, or state flags or shift flags. I forget exactly what it's called, but I'm going to call it get keyboard flags. This will return within AL, it'll return a byte with bits set according to whether you pressed a shift key or an alt key or a control key or maybe num or scroll lock or something. But it'll be a little bit simpler to check for input if you only have a few controls that you need. Like for this game, the only controls I need are like move left, right, and shoot. That's only 3 things. So I can check if we pressed like left shift and right shift or alt, right? If all we need to do is move left, right, and shoot. So this is a way to save a couple bytes if you only need like 3 movements or something, 3 or 4 actual keys for input. We're going to get the keyboard flag. I'm going to do a test on the AL byte that was received. So AL1, if we test with 1, we're checking if the first bit was set, bit 0. Compare does a subtraction but does not change the operands. Test, I think, does a bitwise and does not change the operands. So if the first bit of AL is set, then ANDing AL with 1 would give a non-zero answer. If the first bit of AL is not set, ANDing with 1 will give a 0. So then we can go on to check whatever next control we're going to check for, or go on to the delay timer and continue the game loop. But in this case, testing AL with 1 is going to check if right shift was pressed down. So the right shift key, if it's pressed, will set the first bit from this get keyboards flags BIOS interrupt. But if it's not set, we'll go on and check if another key was pressed. So I'm going to go on and do left shift in this case. My controls for this are going to be left shift, right shift, and alt. I'll check the right shift first. If not, I'll go and check the left shift. You can do it in another order. That's fine. I'm just doing it here to be like ascending bits to check. This one I'm going to test AL with, is it 2? Yeah, it's 2. And if that's 0, I'll go on and check if Alt was pressed. So I'll have a check Alt down here. We'll test AL with 4, no, 8. Okay. So this is check if Alt was pressed, either Alt, either left or right. And then if nothing was pressed, we can go on to the delay timer, continue the whole game loop, go to the next iteration. But if one of these was pressed, we can do the controls. If they pressed right shift, we want to move right. So what I'm going to do is basically add a number to the player X value, which I moved into SI conveniently. So I can add to that byte at SI some number. So here when I'm doing on QEMU, AH stays 2 after this. But I'm going to put some BIOS may clobber AH, QEMU. Let's get rid of this. QEMU does not. So AH will stay 02 after this call. So what I can do is add AH here to save a byte, and this will add 2 to player X, move to the right. And we can do something similar to the left shift. If we want to move to the left, we would add a negative value instead of a positive value, or instead of adding 2, we can subtract it. So subtract 2, move to the left. Okay. And I'm saying Alt is the player shot. I'm going to create the shot here. So I'll do create player shot. I'm going to do a load string byte to move the player X value into AL. So AL equals player X. That means we moved on to, if we set player X to SI over here, and we did the load string byte down here, that means SI now points to the shot array. I'm going to say the first word, the first 2 values of the shot array are for the player shot, X and Y. So SI would point to the Y value right now for the player shot. So what I'm going to do is exchange AH and AL so that AH equals player X and AL will equal 2 from the AH value above here. And then I'm going to sort of add a pseudo magic number to this. I'm going to add 035A and hex to the AX value, and I'm going to move that into SI. So what am I doing here? I'm setting a new set new player shot YX values from AX. So if AL is 2 for the Y value, it's 2 from this AH. I want to add a number to that to sort of spawn the shot right above the player sprite. So if the player sprite spawns, with the player Y value, which is 93, I want to add a value to that 93 or subtract a value from it to get right above where the player sprite is. So AL equals 2 plus 90, which is 5A in hex, equals 92. 92 is player Y minus 1, which is right above the player sprite. AH equals player X, add 3 to spawn shots in the middle-ish of player sprite. So it won't be exactly in the middle because 8 is an even number. I can't get if I'm drawing 1 pixel, I'm going to try to spawn it above this point in the player sprite, but I can't really do it in the middle because I don't have this as 3 lines to put it above the middle part. But anyway, I'm spawning the X value sort of in the middle of the ship to look better. The Y value I'm making right above where the player spawns. When we check the shot on the next game loop, it won't hit the player. It'll spawn right above the player, so we can, keep the comparison above so we don't get a game over immediately. And we can spawn it from the player to look like you shot, a shot. And that's all I have to do for player input. So it's not that bad. even though we're not drawing the shot, we should be able to move left and right at this point. Yeah, so if I press right shift, it moves to the right because we're adding 2 when we do that. If I press left shift, it moves to the left because I'm subtracting 2. Alt will not do anything because we're not drawing the shot, but technically it is setting the values. Okay, but we can move left and right now, so that's cool. Okay, let's go ahead and draw the shot on the screen so we can actually start, moving and hitting stuff. I'll move the color in. By default, I'm going to assume it's the player shot. If it's not, we'll move the other color in, but I'm just going to set it to begin with to the player shot. So player shot color goes into BH. SI at this point, again, would be after the load string word here, so it would be on the YX value of the next shot compared to the one we're checking and drawing. So I'm going to move into AL the Y value from the previous one that we're actually drawing right now. Okay, and if it's the player shot, I'm going to move it up. So I'm going to decrement AX, move shot up. Okay, I'm comparing to 4 because up here we moved 4. We have 4 shots to compare against. If I'm saying the first shot is the player shot, CL will be 4 still until this pop in this loop. So the first shot, the player shot, CL is going to be 4. Any shot under 4, 3, 2, 1, is going to be the 3 alien shots. So I can compare 4 to see which one we're on. So if it's not equal to 4, it's an alien shot. If it is, it's a player shot. So if it is equal to the player shot, I'm going to say draw. But if it's not equal to 4, then it's an alien shot. So I'm going to move the alien shot color into BH. Is shot the player shot? No, go on to draw. I'll put no, this is alien shot. This would be yes. Yes, go on to draw. Okay, otherwise we have an alien shot. We want to draw that color instead. And instead of moving down, we want to move, or instead of moving the shot up, we want to move it down. So since by default I decremented, I'm going to put a couple increments here. So one increment would make it equal before this decrement, and then another one to move it down the screen. And then we're going to see if the shots hit the bottom of the screen. So I'm going to compare to screen, is it screen height? Yeah, compare to the screen height divided by 2. Because we're scaling everything by 2, we don't need to compare to the height. We need to compare to the height divided by 2. So did shot hit bottom of screen? If it did, it'll be greater than or equal. And I'm going to move BX into AX. So this will effectively set AL equals 0. So AX equals BX if so. If it hit the bottom or it's past the bottom of the screen, AL equal to 0 from BX equal to 0 above, right? So BX is 0 above because above all this crap, we have an XOR BX here. So if we didn't hit anything and we're going on to draw the shot, that means we will have skipped over this barrier check, skipped over any alien checks. So BL would still be 0 at this point from that XOR BX. So I can move that 0 into AL with this C move greater than equal. Compare and move if greater than and equal. And the reason I'm doing this instead of like a jump greater than and equal down to draw, and then a move BL into AL, and then we'll have a draw thing down here anyway. The reason I'm doing this instead of these 2 lines is because it took up the same amount of bytes and it's one less line of code. Pretty much. I'm a simple man. I like some things to be simpler. So readability, lines of code. Okay, but if we actually go to draw the thing into the Y value of the shot, I need to move the new AL. So set new Y value of shot. Because SI is pointing to the next one, we need to move it again into the previous Y value, reference it by -2. And then since we have the color in BH, I'm going to move that into BL. I'm going to exchange AX with BX, put color in AX, and then I'm going to draw the color on the screen, similarly to how we did in Draw Sprite. I'm going to draw it to the current row +1, so the next row down on the screen. So DI plus screen width, I'm going to move AX into that, and then I'm going to do store string word to move into the current row on the screen and move DI for the next. So, draw 2 pixels, 1 row down on screen. Draw 2 pixels on current row. Okay, and then after we're done drawing the shot, we can go to the next one. So jump to the next shot. The reason I'm doing a move BH into BL and an exchange is because if we did move BH into AL and then move AL into AH, this takes up 2 bytes and this takes up 2 bytes. If we do a move BH to BL, that's 2 bytes, but this exchange here is a 1 byte instruction because we're doing an exchange with AX or EAX. That's 1 byte. So this would be 3 bytes overall instead of 4 bytes overall. It saves 1 byte. You got to save them where you can. So that's why I'm doing that. But this should draw the shot on the screen and move it up or down, depending if it's the player shot or the alien shot. Okay, if that makes sense. So now we should be able to press Alt and actually shoot and have it move up the screen and hopefully destroy a barrier, but we won't be able to hit the alien yet. But let's see, we can move left and right. I press Alt, the shot moves up the screen. It's not going to hit the alien. It's going to go on until it reaches the top. It's going to disappear until we shoot another shot. But since we have the check barrier set up, that whole loop, we should be able to erase parts of the barrier now. So it gets the X value, you know, it offsets into the barrier by X, it offsets with the Y value to get the row, and we can erase that pixel in the barrier now. If you erase all the pixels, then the shot will go on through because it doesn't hit the color of that barrier anymore. And that column, you know, that Y value that the shot has. So that's how you do, you know, destructible barriers. You kind of find the pixel for an X and Y offset within the barrier that you hit or within the sprite that you hit, and you can erase it with a bit test and reset. So now we'll go on and we'll do the check alien logic so that we can erase the aliens. Okay, let's see where we're at so far on space. We're still looking pretty good. That's nice. Okay. Let's go and see if we check hit alien. Is that what I called it? Yeah. So check hit alien. Let's do this part of the code. So before we go and check, again, I'm going to do like the comparison we have right here. This is the player, the one that the shot we're currently on. Is it the player shot? So compare to 4. Yeah, if we are on the player shot, we can check if we hit the alien. I don't want the shots from the aliens to hit themselves because they would just erase themselves. That wouldn't be good. So if it's not the player shot, we're going to go on to draw the shot. But if we are on the player shot, we need to check if we hit the alien here. So I'm going to see, did player shot hit alien? Because at this point, AL would still be the screen position byte from moving it up here. So if it's not the player color, if we didn't hit the barrier from the barrier color, I'm checking if we hit the alien color. So if we did not hit the alien color, then I'll just draw the shot. We didn't hit anything. If we did hit the alien, and it is the player shot, then we need to erase the alien. So to be able to do that, we have to find the right one that we hit. So we have to loop through each row and each, you know, alien within each row, right? Like the barriers up here, where we moved barrier array, into BX, I'm going to move the alien array into BX here. And I'm going to move into AX, some sort of offset from SI, or an offset from BX rather, to get the alien Y value. So I'm going to start checking from the top left of the aliens on the screen. So the top left alien is going to be equal to alien Y and alien X, right? Where we started drawing them on the screen. So the alien Y here is FA2D. The alien array is at FA20. So this is 32. 2D is 32 plus 13. So we should be able to do BX plus 13 to get the alien Y value. So AL equals alien Y, AH equals alien X. And I'm going to add to AL, to the Y value, I'm going to add the sprite height. So this will get the bottom of the sprite, bottom of alien sprite. So we can check if we're less than or equal to the bottom of this sprite to see what row we're on. If we're less than or equal to the bottom of the first one, we're in the first row. Otherwise, we can add the offset to get to the next row of aliens. If we're less than and equal at that point, we're in the second row. We have 4 rows, so we'll have to do this up to 4 times. I want to get the row that we hit, so I'm going to check for Y values that correspond to the row. So compare DL to AL. So since DL at this point from get screen position We saved off the y and x for the shot within dx. dl is still the saved off shot y position. So I can compare using that. So compare shot y to current alien row y. And if we did not hit the current row, it would be less than or equal if we did hit the current row. So if we did not hit the current row, it'll be greater. So I'll go to the next row. We'll do that. Do any, I cannot type, any x, there we go. We'll hit the next row, okay. So next row down here, we'll add an offset to get to the next alien row. So we're gonna add to the y values we're checking against. So I'm gonna add the sprite height +2, because when we drew the aliens, that's what we added between the rows to draw them at. So I'm adding that same offset here. So I could maybe make that another constant, like alien y offset, and that would make more sense, but you know, I didn't do that, so that's what I'm doing. We'll add the add that, and we'll increment bx. So if bx is pointing to the alien array, that's 4 bytes, 1 for each row. When we go to the next row, we need to increment, so we're pointing to that next row in the alien array. And then I'll jump back to get alien row. So I'll jump back to here, we can check the next y value. If it's not equal or it's not right, we can get the next row, so on. We know we hit one of them because the color equaled from the shot. When we find the one we hit, we need to check which alien within that row was hit. So get alien within row that was hit. There are 8 aliens in each row, so I'll start off with 8 into CL. I'm going to add sprite width to AH. So this would get the right side of current alien sprite. So the same thing like we checked the barriers against, we got the right side that we're initially checking. I'm getting the right side of the current alien that we're checking. If it's less than or equal, then the x value of the shot is within that alien. If it's greater than, we add an x offset to check if it's in the next alien, which it would then be less than or equal. And then I'll call this like, instead of next row, I guess it would be next alien. Yeah, but this would be get. We'll get this first. I'll compare DH to the AH. So compare shot X to alien X value. The right side of the sprite, that X value. And if it's after, or above, sorry, below or above, the A is above. If it's greater than, for an unsigned comparison, it's above. So I'm gonna jump if above to the next alien. The reason I'm doing, I don't know if I explained that before either. The reason I'm doing unsigned comparisons for the X values, for the barrier and the aliens, is because, again, our screen width is 320 pixels. Half of that is 160, but 160 is still above 128. If we did a signed comparison on a byte value here with X, and it's above 128, the highest bit would be set within the, you know, the 8 bits in the byte. So DH here is a 1 byte value. If it's above 128, like with AH here that we're doing a comparison with, the highest bit would be set. If we're doing a signed comparison, which is the greater than, less than, a signed comparison would compare with that top bit set, and it would count as a negative value. Our shot, if our shot is above 128, and we're doing a signed comparison, DH here would be counted as negative. And this greater than would not work. A negative would always be less than whatever we're comparing against. Well, it could also be a negative value, but if we make it unsigned, that means, you know, we have the full 0 to 255 range, and we'll never get the 255 anyway, but if it's on the right side of the screen and we're at X value 150, it's not going to be counted as negative. It'll be counted as positive. So we need the after, or the above, jump if above, unsigned comparison for that. And then the next alien, we have that little label here. I'll add the X value offset to AH, which will be sprite width +4, because that's what we did when we drew the aliens. We had the sprite width +4 as the X offset. I'm adding the same offset here to get to the right side of the next alien, which then if it's less than or equal or unsigned, it'd be below or equal. Then we'd get the right one to get rid of. And then we just go back, right? Yeah. I do that, and then I jump back to get alien to do the next comparison. Okay, but we do that until we get the right alien in the row. Once we found it, we got alien in row. Now erase it, or get rid of it. And the way to do that is, again, we're going to do a bit test and reset against the data in bx, because we incremented to get to the right row. And now that we have the right sort of column within that row, okay, I used CL for that. So since there's 8 aliens in each row, and we initialize CL to 8, we can use CL as the sort of X offset to bit test and reset with. But the bit test commands are 0 based, so we do need this to be, if we hit the first one, this can't be 8, it needs to be 7. So I'm going to do each comparison here, I'm just going to decrement first off. So that way, if we did hit the first one, CX would already be decremented, it would already be 7, and this would be correct. Otherwise, when we get the next one, it'll decrement again. Okay, so this would get the right one. So reset bits, an alien array to erase. And then now that the shot has been fired and it hits something, we need to reset the Y value of the shot again, like we did when we hit the barrier. So SI again is pointing to the next shot, so the previous one is the Y value for the previous shot is 2 bytes before, so SI minus 2. I'll move 0 into there. I don't think I have anything guaranteed to be 0 at this point, unfortunately, which means I have to specify how big data we're moving. It's a byte. So reset Y value of shot. And now that we hit something, I don't think this is 8 anymore, so I'm going to have to change that. But we need to get the number of aliens here. This thing that we set to 32 initially, right here, number of aliens, that I might change later to not need, but right now we still need it. The number of aliens still left alive, this is at position 2F. And if we're guaranteed to be, this is the player shot, which would be the first YX values in this array, and we're 2 after, that would mean SI points to 27H. So 2F minus 27, what is that? We do 2F minus 27, should be 8, okay. So we can do SI plus 8. Num aliens minus 1. But again, if I refactor to not need that, then we can get rid of this line, which would be good. But we need to do that because when this hits 0, we've won the game, even though right now I only have 1 game over condition. But this is what I'm doing to check against that. Last alien is dead, 1 game. Yeah, there's no more left, you won the game. Okay, but if we didn't win the game, there's still aliens left. We did go through and this shot is finished now. We reset it so we can go to the next shot. So we'll just jump back up here to next shot and then we'll go on our way. So that should effectively erase that bit in the alien array that we hit. And then when the next game loop happens and we draw the aliens, that one should be skipped over from this bit test here. And then it should not draw that alien in the array, so it should be erased. So let's just check if that is true. If I go and hit this third one on the bottom row, try to hit it, it should be erased. There we go, we hit his hand there, because that's the furthest to the left pixel. If I go here, slightly to the right, it should hit him in the middle, it erases. And then we can get the one on the last row. So it'll only check if we hit the alien again if the shot matches the color. So since there's none left in this column, it won't ever hit like the green color. It'll just go to the top of the screen. But if we hit one over here, we reset our shot by pressing Alt, it'll get the next one. Anyway, we can hit the aliens, we can hit the barriers. All that's left to do is add some challenge into it. We'll move the aliens and then have them create their own shots. And that should be it. So let's go and make the alien shots here. Sort of, hopefully, pseudo-random positioning, but they're going to be more predictable than random. Create alien shots. So when this is called, it will be after all of the check shots, if we draw them, or we erase part of the barrier, or we erase the alien. After all the shots in the array have gone through, this will be over. We're going to go to, create alien shots over here. That's the only place it's called from. So at this point, we can guarantee that SI is after all of the shots. It's on alien Y. So if we want to go back and loop through all of the other shots to update them or to create them if they've been erased, we need to subtract to get to that point. So the first shot in the array is the player shot. The second one is the first alien shot. So the second one would be 2 bytes after the start, so it would be FA27. Right now we're on alien Y, which is 2D. So D is 13, it's 7, so we should have to subtract 6 to get there, because 6 plus 7 is 13. So let's subtract SI6, our first alien shot Y value. And then since there's going to be 3 alien shots, I'm going to have a loop, so I'll just set this up first. Set CL3. And then to check each one, I'll have a little label check shot. And we'll loop back to this. Okay, so to check each shot, I'm going to be sort of overriding the values in each one. And to overwrite the values, I'll probably use a string operation. So that'll be writing to DI. So first off, for each shot, I'm going to move into DI, the SI value. So DI pointing to shot YX. I'm going to load string word. So now AX equals the current shot's YX. SI will point to the next shot, but AX would be this current shot's YX value. And then we can update AX and then move it into DI to update the shot. So I'm going to compare AL to 0. Is shot Y 0? Is the shot 0? Is the shot not in play? Has it been reset? Did we hit something? If it is 0, we want to make the shot. If it's not 0, it's still in play, we want to go on. So if it's greater than 0, we want to go on. So I'll do like next shot. And I'll have this down here. Next shot is just going to be a label pointing to this loop. You could also put it like over here. This will be equivalent, but I think that looks a little jank. I don't usually like doing that, just for me personally. But I'll do this, so it'll basically go on and just loop back. Instead of putting another loop here and making it weird, I'll just do that. But if the shot is 0, we want to create the shot. Y value is 0, create the shot. But yeah, we're creating the shot. It's going to be a sort of pseudo-random number. 0 through 7. So I'm going to try to make it a little randomish between 0 to 7 to sort of offset into the alien array here. So I can, spawn the new shot under one of the aliens in each row. So I'm going to use the timer to do that. So since the timer is in the BIOS data area, it's still offset from the code segment. So I'm going to put the code segment prefix here because the data segment points to, our screen memory effectively. It won't point to the timer. It would be wrong. So I have to use CS instead of the implicit DS for data segment to get the right timer value. And what I'm going to do is AND that value with 7. So this way we only get, or mask off or whatever, the lowest 3 bits. We want to mask off the lowest 3 bits to get a number 0 to 7. And then I need to basically offset that 0 to 7 into a column in our row of aliens to spawn under a random alien. So a way to do that is to multiply the 0 to 7 by the space between each alien on the screen, which the X offset when we draw them is the sprite width plus 4, right? That's a 3, but I'll change that. Yeah, the sprite width plus 4. In between, the spacing between the aliens, we can add that or multiply whatever 0 to 7 number we got multiplied by that, and we'll put it into AX. So multiply AX by that and, put the result in AX here. After I do that, I had an exchange with AL. So move, so this is kind of the X position that we're getting here. So get X position to spawn shot at, and I'm going to move that to AH. Move X position to AH, AL equals 0, because AH was 0 after this AND right here. The highest value we're going to get is 7 times this, which is 12. So 7 times 12 is what, 84? So that'll be, well below the 1 byte limit. We can just move that into there. And that also has the beneficial effect of setting AL to 0. And then I can add the alien Y value. So add alien Y to AL. So AL will equal alien Y. And the alien X position will be added to AH. So I'm getting the offset, and then I'm adding it to the start of the alien row, right? The alien X value that we initially draw the aliens at, so that'll be the left side of all the aliens. I'm using this X offset here to offset from that to get a position to draw the shot at. So that's why I'm adding the initial X position here. And then the alien Y, we're going to spawn the shot basically at the top of where the aliens spawn. So it might look a little jank if the top row is blank, but that's fine. And then to move that new position, that new XY position, we'll move it into DI. So that'll move into the array because we initially set that shot to DI up here. So now I'm moving the value into DI with this store string word. And that way DI will increment to point to the next shot, whereas the load string word will then load that next shot, so we'll be good to move through all 3 shots in this loop. It's kind of hard to say words today. I'm talking a lot more than I usually do. So after we make 1 shot though, I'm going on. If we made all 3 at once, they would all be at the same sort of vertical level, the same Y value. If I move on, get player input and draw everything, at least 1 timer tick will have passed for the next loop iteration. At a minimum, the next shot will be at least 1 Y value higher when it's created and drawn. So this way, all the shots aren't at the same Y value. They're all like, like staggered in a diagonal line or at, different Y values on the screen. Makes it look a little better, a little more random kind of, but it's not really that random. But we'll go on after making 1, and then that should be all we need to do to make the 3 alien shots. So it's not too bad. Sort of pseudo-random. What I probably should do instead is like, I don't know, get a better timer value somehow, get a better random value. And instead of anding, I should probably like multiply by some random 0 to 7, I should make it more random, but right now I can't do that. Move aliens is undefined, that's good. Oh yeah, I need to make a label for that, there we go. So that will jump down here when we're done. And there we go, got rid of the errors. So now we have some alien shots going on. They're spawning at roughly different Y levels. If it hits a barrier, that barrier pixel is disappear. So now we have the added effort of dodging the shots, right? And then we can get rid of them. And remember, if we get hit by one of these, it'll be game over. Because the shot value is checked against the player color, it hits it, so game over is just pausing right now. So now we can lose the game, so that's good. I'll change the reset to actually reset. That would be good, wouldn't it? So instead of just halting, let's take in a keystroke, any keystroke, so with int16h, with the BIOS interrupt int16h, and then I'm going to reset everything. You can do that in one of 2 ways, or maybe other ways. QEMU, you can do an int19, and this will reset QEMU. Or if you want to be a little more general, you can do a far jump to FFFF0, right? Or the reset vector. So if we do a far jump to the reset vector, so effectively FFFF0, that's the x86 reset vector, it'll reload the boot sector and everything. Effectively, it'll do the same thing as int19. It takes up a couple more bytes, of course. But we're doing 2 words and then a jump. So this is probably like 5 bytes and this is like 2. So if you really need to save some, then use this for QEMU. But otherwise, I'm going to go for the more general purpose reset here. Reset by jumping to reset vector. What's your vector? That way, if we hit something, or if we get hit by a shot here, then it pauses. We press a key. We can't press the keyboard flags keys like Shift and Alt aren't going to do anything. But if we press a regular key like J or T or something, then it'll reset and we can start over again. That's how that works. Okay, but the last thing we need to put in is actually moving the aliens, so let me go ahead and do that. See, there's the not random where they all spawn like next to each other, but the shots are kind of random here, so that's good. Okay. But yeah, I'll remove that little to-do here, because we did that. This is just a sort of alternate reset. I'll do this alternate resets to save bytes. This will be reset QEMU specifically. Box has its own thing, I think, but yeah, I'll be general with the reset vector. But yeah, the last thing we should do for this is going to be move aliens. Let me check right here. We should have enough space to do that. If not, I'll move some stuff around. So we do have one register that we haven't used yet, and that is the base pointer. So I'm going to use that to hold our current move timer, our amount of game loop timer ticks, right, that we set to 18 initially before we're going to move the aliens. I'm going to use BP as a comparison to that to see when we need to move. Using the base pointer for move timer, because push and pop only affects the stack pointer, BP is unaffected. It should be okay, and it should start at 0. Again, I'm assuming it's 0 because in QEMU it is, but that's just how mine is working. Okay, so I'm going to move alien X to DI, and I'm kind of going to use that value and offset from it to check these other values down here, move timer and stuff. So just moving alien X into DI to start off. I'm assuming the base pointer starts at 0, so I'm just going to increment, and if we reach the point that we need to move, it will equal the move timer, and we can move the aliens and then reset it. So I'm going to compare it to alien X plus 1, 2, 3. So that would be DI plus 3. If they did not, I'm going to go on and get player input. We don't want to move yet. We'll go in the next go around, we'll increment again and check if we've reached the move timer value yet. But if not, we'll just go on. If we did, we want to move the aliens. So I'll do that here. So what I'm going to do is reverse the direction that the aliens went by... Sorry, each time we move the alien, I want to change the sprite to the alternate sprite, so that's what I'm going to do here. So this change alien value, I'm going to negate the byte. We started at 1, and then I check down here when we draw the aliens. I'm comparing that byte. If it's greater, so we started at 1. If it's greater than 0, 1 is greater than 0, then we're going on. If it's not greater than 1, it's less than or equal to 0, then we're going to use the alternate sprite. So the way I can toggle between greater and less than or equal to 0 is toggling between 1 and -1. So an easy way to do that is just to negate the value. So that's what I'm doing here. So I'm going to negate this byte. So DI is alien X, that is 2E. And this is 33, which is 51. 51 minus 46 is 5. So, or you can count, you know, here, 1, 2, 3, 4, 5 bytes difference. So DI plus 5, I'm going to negate that byte. So I'm going to toggle change alien bytes between 1 and -1 to draw the next sprite. So we'll negate the bytes. I'm going to reset the move counter in BP. Reset move counter. And then I'm going to get because the next time we go through, we'll increment again till we move again. I'm going to get the direction that we're moving, the number of pixels we're going to move the aliens, I'm going to put into AL. So that is this value plus 2. So this here, number of pixels to move. Okay, and then I'm going to actually move the aliens. So I'm going to add to the alien X value, which I moved into DI. This is why I initially did this. I'm going to move into that AL. So that'll add a positive or negative value to alien X. So when the aliens are drawn again on the next game loop, they'll have moved this many pixels over on the screen. And then we need to check if they hit the boundaries, the sides of the screen. So I can compare, well actually the add. The add will affect the 0 flag, the add instruction. So we can see if we're moving in a negative direction, we will have hit 0 because we'll be moving to the left. So if they hit 0 or they're less than 0, we need to reset basically the alien X to 0. But since add affects the 0 flag, we can just do a comparison here. If we did not hit the left side of the screen, then we can check if we hit the right side of the screen. So check hit right side. Did not hit left side of screen. X equals 0. Okay, but if we did, we want to reset to 0. So I'm going to move into DI CL, because CL is 0 at this point. Did hit left side, reset to 0, CL equals 0 after check shots. After we loop through all of this, right, this check shot loop right here, CL is 0, so we can use 0 as this value to compare against. After, let's do create alien shots. Yeah, so CL is 0, this will save 1 byte compared to just using the 0 as a constant. We'll use the register, saves a byte, so might as well. And then we'll go and move down. So I had a move down thing here. Because every time the aliens hit the left or the right side of the screen, we want them to move down the screen and then get slightly faster. So that's what this will be. Okay, if they didn't hit the left, we want to check if they hit the right side. So we will compare the byte DI to AL, but I'll use a different value for AL. I'll move 68. So this is a magic number, right? Unfortunately, but this is approximately the right side of the screen. It's within like a couple pixels when the alien's moving over. I'm basically just checking if the whole block has reached the right side of the screen. I'm not checking if the rightmost alien has, which would be better, but I'm checking if the whole block, you know, of aliens has hit the left or the right side of the screen. So basically if the alien X value, which is the first one on the left, has hit the left or right. This won't line up when we get rid of a bunch of the aliens if we're good shooting them all down. This will look kind of jank because they'll just be moving in the middle. But, you know, you could make it better and save some bytes if you're good. I'm not good. Try to change to use leftmost, rightmost aliens for comparisons. Don't just check top left alien. That would be better. That's not what I'm doing. Oh well. If we did not hit the right side of the screen, it'll be less than or equal, and we can move on. And basically go to get input. We didn't hit the left or the right side at this point, so we can move on. But if we did hit the right side, we need to correct and move down. So if we did hit the right side, I'm going to set this byte by moving the 68 and AL into alien X that we set with DI up here. I'll use store string byte, and then I'll guess decrement DI. Hit right side of screen. No. Go on. Yes, correct. Correct to 68. Okay, but when we hit left or right side and we move down and go faster, the way to do that, to reverse the direction so that when they hit the left side, they'll start moving right. When they hit the right side, they'll start moving left. One way to do that is to negate the direction byte that I set. That's what I did here, right? Yeah, we'll negate DI plus 2. Put this back up here. That'll be this byte here. So it'll move from 5 to -5. They'll start moving, or -5 to +5. They'll start moving in the other X direction. Move in opposite X direction. And I did a decrement. Okay, and then I'll add. So if we're currently on alien X, alien Y is 1 byte before this, and memory up here. So if I want to move the aliens down, I need to add a value to that alien Y. So that's what I'm doing here. So I decremented to move the I back to alien Y, and I'm going to add a value to that. I think I'm just adding 5, yeah. Or add to alien Y value to move down. And then we can compare if they reached some area on the screen. So I'm checking as a second lose condition. I'm checking if the aliens sort of breach the barriers on the screen. If they move below the barriers, they're kind of on the same row or near enough to the player. So you basically lost the game at that point. So I'm just saying this is a lose condition. I'm comparing the alien Y value to barrier Y. And if they pass that point, they pass the barriers, I'm counting that as a game over. So if it's greater than, if it's less than or equal, it's okay. But if they pass the barriers, it's greater than that Y. And we're going to game over right there. Did aliens breach the barriers? All right, if they did, I'm doing a game over. Yes, lost game. Put a little tear, you're crying. Okay, but if we didn't lose the game yet, I'm going to make the aliens move slightly faster by decrementing that byte. So at this point, we're on alien Y. So plus 1, 2, 3, 4. 4 bytes is the move timer. So I'm decrementing that byte. Aliens will get slightly faster. And I think that's all I did to move them. So they'll move to the left and the right. When they hit the side, they'll move the opposite X direction. They'll move down and go slightly faster because the move timer will move from 18 to 17 to 16 to 15. It'll be less game loops before they start moving again. So they'll get a little faster each time. We should all be good now. I think the game is about done. Okay, we have a couple bytes left. So the way I did it before, I saved a couple more, but this is close enough. Again, there's a couple of things I marked down that we could have done to maybe save some bytes or look into in the future. You're free to do that on your own, I guess. I just want to make sure this works right now. Have our complete game, hit the barriers, we got the aliens doing shots. We can hit them, get them out of the sky, get them out of there. The X value comparisons over here will work because they're unsigned. They hit the right side of the screen, they move down, they'll get slightly faster. We gotta dodge the shots. So we got a sort of full-fledged game here. Again, if you remake your shot, well not again, but if you remake your shot before it hits anything, then it won't hit anything. So keep that in mind. If it's here and you redo it, it's not gonna hit anything. So keep that in mind. But yeah, there's 32. It's fairly, I mean, it's not like the most easiest thing, but there is a lot of them. So it does take a while to go through, and if you miss a few times, it might be hard to win, but I'll see if I can win a game here and show that. All that's going to happen is everything's going to freeze and it'll take a key and reset. So one thing to add may be actual win or lose conditions. That might be something to look into, because right now there's no difference. But you know, we get a little sort of game to spend a couple minutes on. That's always good. I will look into other games. I'm thinking either Centipede or Tetris or maybe Asteroids, if I can do those in 500 bytes. It might take me a while. This one took me a while to do. I had to refactor a lot and move stuff around a lot, so it took me about a month off and on. Hopefully this video is not too long, but it's probably going to be like 3 hours. So if it was entertaining or you skipped to this point, I really do appreciate it. Thank you everyone for watching. It's really great. I really do appreciate it. And there we go. I won the game. Hey! So yeah, it just freezes until you reset. And we can start again. But yes, really thanks for watching. I do really appreciate it. I know I keep repeating that, but it does mean a lot that people want to see my boring videos. But maybe I can teach you some space-saving techniques here in assembly. Let me know whatever else you want to see. It doesn't matter what it is. I'll look into it, and I can eventually make a video on it, although it takes me a while currently. I want to be more active, but it's taken a while. So, but yeah, thanks again. I will see you on the next one.